Academy, and the other honorable invited guest. My name is Velia, and I am very honored to be here today as the Master of Ceremony for this event. First of all, let us thank God who has given us happiness, health, and mercy so that we can participate in this special event without any obstacles. Distinguished guests, ladies and gentlemen, before we start this conference, let us sing the national anthem, Indonesia Raya. To all the participants, we would kindly ask you to stand up. Thank you for your participation. On behalf of the committee, we would like to express our biggest gratitude to your presence in this special occasion. Also, we would like to announce some housekeeping notes for this event. Firstly, we would like to have your cooperation to mute your microphone to avoid any interruption in this conference. And last but not least, feel free to approach any of our committee members via meeting chat if you need any assistance. Distinguished guests, ladies and gentlemen, we will start today's event by listening to the opening speech by the head of Informatics Department. Then we will continue to our first lecture by Mr. Vijaj Walunj, Ph.D. and a short break, followed by our second lecture by Mr. Khairul Answar, Ph.D. and another short break. And finally, we will have our third lecture by Associate Professor Agustian Taufiq Asyhari, Bachelor of Engineer, Ph.D. Distinguished guests, ladies and gentlemen, to start today's conference, we would like to call upon the head of Informatics Department, Dr. Aris Pujiwidodo, SSEMT, to give his opening speech for this event. Without further ado, Dr. Aris Pujiwidodo, SSEMT, is now pleased to come to the stage. The time is yours.
Thank you, Prof. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, and Salam Bajikan. Honorable Speaker for today's public lecture, Mr. Vijaj Walunj, Ph.D. as Technical Lead R&D Teledoc Health, Mr. Khairul Answar, Ph.D. from Vice President at B.Eng, and Associate Professor Agustian Taufiq Asyhari, Ph.D, from School of Computing and Digital Technology and Head of FinTech Research Cluster, Birmingham City University. And my beloved lecturer and student department Informatics, Diponegoro University, distinguished guests, ladies and gentlemen. First of all, let us express our gratitude to Allah Subhanahu wa Ta'ala, the Almighty, because for His blessing, we are still given the opportunity to be able to gather online in today's public lecture. The theme for today's public lecture is App 101 from communication technology to UI pattern. As we know, we are currently living in the era of technology. Every aspect of our life involves technology, from simple web, from managing record to complex IoT system. As academician and IT practitioner, we have so much to learn, from design database, creating beautiful front end, managing reliable back end, and up to creating smart system. Today, public lecture is held with the aim to highlight some of the important aspects in the development of technology, ranging from creating front-end, reliable software, and managing smart system. Last but not least, I would like to thank all the committee and all those who have helped organize this event. I hope that with this event, we can continue to collaborate to research, learning, and student etching and others. We hope that today's public lecture will be able to provide an insight and update on the application of recent technology. Please enjoy the today public lecture. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Aris Pujiwidodo, SSEMT. And at the moment, we will proceed to the short photo session. For all participants, we would like to have your cooperation to turn on your camera for this session.
Okay, everyone, let me take the photo session. I'll take for the first page. Please give us your best smile. 1, 2, 3. Okay. Next, I'll take for the second page. For everyone, please give us your best smile. 1, 2, 3. Okay. Thank you very much for your cooperation, everyone. I'll give it back to the MC.
Thank you, Mr. Sandi, and thank you for your cooperation. Distinguished guests, ladies and gentlemen, for the first session, we are very pleased to welcome our first speaker, Mr. Vijaj Walunj, Ph.D., the technical lead of Teladoc Health Research and Development. And the moderator for the first session is our very own researcher, Mr. Panji Wisnuwirawan, STMT. Without further ado, please welcome Mr. Vijaj Walunj, Ph.D. and Mr. Panji Wisnuwirawan, STMT.
Okay, well, thank you, Velia, for the time. I'm glad for the opportunity to be the moderator of the session. The Honorable Head of the Department of Informatics, Faculty of Science and Mathematics, Universitas Diponegoro, Dr. Aris Pujiwidodo, the Honorable our visiting lecturer, Dr. Vijay Walunj from Teledoc Health, the honorable lecturer and staff of Department of Informatics, Universitas Diponegoro, the honorable all participant student of Department of Informatics, Universitas Diponegoro. Good morning and Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, we are able to join this event, visiting lecturer held by Department of Informatics. And good morning, Mr. Vijay. Dr. Vijay, good morning. Good night, yeah.
Good evening. Good evening.
Good evening. Good evening.
Good morning.
Okay.
Good evening.
Okay. Well, in this special occasion, we have our special lecturer, Dr. Vijay Walunj, technical lead or manager of Teledoc Health in New York. So we would like to give our special thanks to Dr. Vijay for joining this event. And then before we start the session, it is my great pleasure to introduce the profile of Dr. Vijay. Dr. Vijay Walunj achieved his master's degree from the University of Missouri, Kansas City in software engineering and Harvard University for data science. He also have Ph.D. from University of Missouri, Kansas City in software analytics. His publication is mainly in the field of software engineering and also deep learning in relation to software engineering. So his subject matter experts are related to software engineering. Dr. Vijay is currently a technical lead or manager of Teledoc Health in Purchase, the New York City, United States, a company that is offering technology to connect and improve health. Distinguished participant, today Dr. Vijay is going to talk about one of the current interesting topic in software engineering, especially in software evolution. In this session, we have two agendas. The first agenda is the main lecture from Dr. Vijay, about 90 minutes. And then we will continue to the second agenda, that is a question and answer for about 30 minutes. We expect participants to be actively participate in the question and answer. And during this session, you may type your question in the chat panel, or you may also deliver your questions directly to Dr. Vijay in the question and answer session. Well, ladies and gentlemen, let's start the first agenda in this session. The main lecture presented by Dr. Vijay. The topic of the lecture is Graph Evo, evaluating software evolution using machine learning based called graph analytics and network portrait divergence. Dr. Vijay, the stage is yours.
Okay. Good morning, everyone, and thank you for joining my presentation. I'm Vijay Walunj, a recent UMKC Ph.D. graduate and a tech lead at Teledoc Health. I would also like to thank Prajanto and the organizing committee to make this presentation happen. My research topic at its core is about software analytics. As you can see, each software basically goes through such steps like requirement engineering, system design, implementation, testing, deployment, maintenance, and then the circle continues. So, so software evolution is basically the process of developing, maintaining, and updating the software for various reasons, such as requirement changes, defects, technical depth, or compatibility with other software. So software evolution is an important phenomenon on its own, given the increasing dependence on the software at all levels of society and economy, as the director mentioned about it. So the successful evolution of software is becoming increasingly critical, and this is an important topic of research that hasn't received much attention. So in the world of all the companies, as all the companies compete with each other on putting better features every day, every week new changes are pushed, and that means that company needs to design their software in a manner that the software is easily extensible and can accommodate newer changes based on the market needs. So all of my current research basically revolves around identifying these changes in softwares at the software level, at the class level, even at the pull request level. I also quantify the differences between different software version and apply the method for the software defect prediction. I will just continue with my primary research areas. So it revolves around detecting and visualizing significant events in software evolution using call graph. This is the study that happens at the software level. Then I move my focus to the more granular level, which is the class level. Class level. Basically, it involves extracting metrics that are suitable for the software comprehension and then estimating the number of defects in a given code entity, example class. So like my objectives 1 and 2 revolves around the class and the software. After that, like in between objective 1 and 2, I collected loads of data, and now once I have that much data, I need to see how I can utilize this data for how I can utilize this data for additional use cases. So my third objective is revolves around building a public bug data set where where the portrait divergence metric, which I will talk about later in my presentation, and also I evaluate the approach for the software defect prediction. Lastly, I go to more granular level at the pull request level. So engineers usually contribute to the code base at the pull request level. So I also have the approach which assists the pull request review process by structurally understanding the code changes. So in all of the research work that I have done, I have mainly focused on Java, but again, as Java is an object-oriented programming language, it would be again applicable even to the other object-oriented programming languages. So this is the agenda. I would just go over about me. I would go over some of the research publications. I would go over the challenges that are there currently in the software domain. And then I would go over the research areas one by one. And lastly, I would just conclude the work and just talk about the future work. Does it sound good? Any questions so far? Thumbs up, thumbs down. Okay. Okay, so this is me. This is basically the slide which I just showcase everywhere I go, the presentation. So I completed my bachelor's back home in India in 2008. And after that, I worked for a couple of companies, Infosys as well, some finance company as well. After that, I decided to pursue my master's in software engineering at University of Missouri, Kansas City. While doing my study, I also worked for a couple of startups, and then also did internships in the company Ericsson. After that, after the internship, I basically started working full time for the company Ericsson, where I built basically first alert suite of tools for our telecom client T-Mobile. So basically, before the customer complains about the telecom network, you would basically have the tooling which would capture the issues within the system and then alert the engineers so that they can take the right action. After that, I worked for a company called H&R Block, where H&R Block is major player in tax business in USA. and I work for them. I've maintained legacy code. I built new platform. I also work on several interesting projects which had a bigger impact of supporting 10 million plus users. Around 2016, I joined the UMKC for my PhD program in software analytics under my professor, Dr. UG Lee. So along with the work, I finished my coursework and also finished my thesis. Currently, I work at Teladoc Health as a tech lead, where I build a messaging platform, and all of the enterprise-wide messaging would basically flow through the tooling which I am building. Along with that, I also love to take part in hackathons, also judge multiple hackathons as well, and would and also work with some of my friends on any research projects as well. That's me so far. These are some of the research publications that I have done over the years. I have been part of like 12 research papers, out of which 10 are published, and then 2 are in review. It includes 4 journal papers as well. I also did 30 plus paper reviews, including 2 journals, and I also did some project in my core discipline about 5G and telecom. So that's pretty much about it. But again, like I love to solve the problem, and then the PhD work has helped me to uh, to uh, to solve the problems systematically, scientifically around that. So that's pretty much about me and the publications. In the current software domain, I see that these are the major challenges which I see at the moment, as I have been in the industry past 10 plus years, have touched multiple projects, legacy code base, newer projects, medium projects. And I see that these are the typical issues that are faced by every software practitioner, and that's where the academics can help. Academic or research community can help them to fix these problems. So basically, the first is like the poor software quality. So the poor software quality has been the cost of poor software quality in US was 2.84 trillion in 2018, and it went to 3.39 trillion in 2020. I saw there is a 2022 report as well, but I have not added that as a part of my presentation. So poor software quality cost has been increasing every year, and researchers have been spending time on trying to separate the issues with overall software quality and that's where the software defect prediction becomes more important. Like it takes like 16% of the overall pie. So like finding or fixing defect basically means some of the internal waste or scraping or rework or some steps that you need to take to produce the defect. So whenever we get a defect, it's basically costly for the company to fix that. So also in newer report, we see that cybersecurity has got its own section. We see that cybersecurity related failures receive their own section, and that's where the software vulnerability also becomes important. Also, better software quality would basically contribute to better fix the software vulnerability as well. So these are the issues with the cost of poor software quality. Then recently, I think I think all major companies and all medium size companies have also started using DevOps, which is in the DevOps. Usually the developers contribute to the source code repository too often every day, and what happens is that developer would work on the problem, they would commit their code to the source code repo. After that, there would be some automated test or automated sanity checks that would happen, and then developer would get the feedback and he would make the fixes based on the item that he sees. So it means that as each company puts new features every other day, and that means that developer would commit more items than what they were doing last year. And even in my current company, I commit average 10 times a day, and that's I think I mean, when I started work, I think it was like a one commit or two commit a week. So this has been kind of the major challenge that I think research community needs to address. So to solve these challenges, what I have focused on is I basically frame my problem statement that I need a way to characterize and understand the software evolution, and I have used call graphs for the representation. So so what I have done is, like, if you see here, version 1 and version 2. So it becomes an important to understand the differences between two software versions, and call graph are the best way to represent the software internals. So this is my problem statement where I focus on software evolution with the objective of characterizing it and understanding the differences. So based on my problem statement, I come up with these four objectives. Okay, so as I mentioned, each software evolves, and there could be minor versions, there could be major versions. So my objective one, as you see here, what I have done is uh, GitHub has so many Java projects in it. So I get the Java project from GitHub. I also use the publicly available defect datasets, and then I use that as well for my Java projects setup. From the Java projects, I also take Java jar files. So like whenever Java-based software is released, there would be a jar file. After Java jar files, I basically generate call graphs from the jar files. So the call graphs are basically showing the interaction between the functions that are defined in the Java programs. After the static call graph phase, I basically convert those into execution paths. So I just try to get all of the execution paths that I find in the call graph. After that, I have introduced a software metrics that can identify the differences between different software networks. And here I mentioned that as a network portrait divergence. Also, along with that, I calculate so many other object-oriented related software metrics. After this stage, after this stage, I basically store the data in the data set. I also do some analysis and generate a prediction model as well. I also take the software level data and analyze the software evolution from the software level perspective. And in the fourth objective, I basically understand the software evolution from the perspective of pull request. So mostly, I think people have been focusing on pull-based development, meaning whenever a developer wants to contribute to a code base, they will use a pull request, and through a pull request, their code changes are merged into the master branch of the source code. So that has been the way for the pull request. So my objective one basically revolves around identifying the significant events in software evolution at the software level. Then for the objective 2, I basically extracted the software metrics at the class level, and then I use a deep learning model to predict the number of defects. Then I also built a public bug data set where I have existing software metrics that are used in research, and along with that I use the network portrait divergence, and then I use that data set and I just compare it with other available defect data set, and I also check its performance with 12 ML models. And lastly, I go like one more level granular where I evaluate the software at the pull request level. So again, I would again stress that all of the work is based on the Java, and then I will go through these objectives one by one. Do we have any questions so far? Are we doing good? That's too many things for the morning, right? Okay, do we have any question in the chat? Which good. Okay, I think we're doing good. Okay. So yeah, the objective 1 is identifying the significant changes in software versions at the software level. Some of the literature review I done is that about identifying the different representation of source code, then generating features from program analysis heuristics. Then I also did some analysis on some benchmark study that I have done. Also I work about measuring the modularity as well. After the analysis of literature review, I try to frame my solution. So here, like these are the 4 building blocks to my solution. So what happens in nutshell is I have the Java jar file. I convert that to a list of caller callee. Then I generate the call graph. I generate the execution paths. After that, I have some algorithm to calculate a software metric at the class level. I also have other software level metrics, and then I show those insights on a dashboard. So the call graph is basically, so here is a simple code snippet of Java code where a main function calls another function A. The function A calls a function C. Also, main function call the B as well. So if you see like a simple execution path, like from main it goes to A, from A it goes to C, and from main it goes to main, goes to B, and also A goes to C. So I see like there are 3 simple execution paths at the moment, and then I utilize those to for my simple execution paths list of items. Then the tooling that I built as part of my work, I also load the project here. I show the new functions added, the classes that are defective, and then some view that people can zoom in, zoom out, and see the actual code structure within the software. So the analysis I did, the first analysis I did was on these 6 applications. Basically, you can see the release number. You can see the number of nodes, number of edges, number of paths, average degree, clustering coefficient, diameter, and modularity. So all of these items I have captured at the software level. Okay, so meaning I have 1 row for each software version. The clustering coefficient, it basically measures the degree to which nodes in the graph tend to cluster. Usually high cohesion and low coupling is expected. Modularity basically talks about modularity basically detects a community structure within the graph. The diameter basically the longest shortest path between the node. Usually you want the diameter to be smaller because deeper the diameter, you would basically your runtime stack would increase, and it would affect your debugging. So now I talk about call graph. I talk about the different metrics at the software level, and then I talk about the network comparison. So the initial idea was that to compare software networks, version 1 with version 2, version 2 with version 3, and identify the changes. So what I did was that I studied about general network comparisons. Okay, so I figured that when we compare two networks, we need to make sure which category these networks belong to. So, so for example, the networks which I am comparing, if the number of nodes in the both the networks not gonna change, then that basically called as a known network correspondence, meaning number of nodes that you are comparing are same. So for example, air transportation network, so number of airports and their paths basically remain same, and when you compare the air transportation network, you'll basically have same number of airports at one point of time. So these are, so that's the example of KNC. And then there is a UNC where the network that you are comparing will have a different number of nodes, and that means that it will have its own challenges, like when you compare network 1 with network 2, you should get one number, and when you compare the network 2 with network 1, even that case you should get the same number. So yeah, so the UNC has its own challenges. So now what I did was that there has been a research around solving these network comparisons for each of the types of network. Here is the full list of the items. I would encourage the researcher to go through this list later and see if that can help in your own research. So in previous studies like Euclidean, Jacquard, Manhattan, distances were kind of prominently used, but we find that the network portrait divergence that was introduced in 2019 is kind of effective for the problem of UNC. And software networks are of the type UNC. So that's why we pick the network portrait divergence as a metric that we can apply to software domain. Also there has been one of the study performed on the comparison of the networks, and found that NPD, the network portrait divergence, is effective. Is effective and specifically suited for structural comparison. With each software release, the count of functions within the class change, the count of classes also change, the connectivity between various classes also change, and the NPD would be able to quantify the difference. So that's basically where I am able to compare the networks. Then now I will go through how the metric is basically calculated. So the NPD, the way it works that we compute the portrait distribution for each software version. So for each software network, there is a distribution of nodes and the length and then the distance between the node. So we form a matrix BLK, which is the L is where the number of nodes with k nodes at distance L. So it basically, so after we calculate the portrait distribution for each version, we basically take the average. Basically, we take the average of the average of the combination. What happens is that we take the average of the like we have the each individual distribution of version 1, version 2, and then we also have a distribution which is the average of the two. After this step, we basically apply KL divergence to each combination of the two software version distribution and the average one. If we have more than two versions, then they are basically processed one by one until the most recent version is reached. Now, averaging the two KL divergence yield the NPD that is used to identify structural changes to a certain class as a certain class. We could apply the KL divergence directly, but the problem is that for software networks, the number of nodes may change and their connectivity will change. Now the KL divergence is undefined when one event is possible as per version 1 and impossible as per version 2. This could mean that version 1 has some paths, but version 2 does not have those paths. So because of that, the KL divergence will fail. But as we use the portrait divergence, which takes the average of the two KLs, it basically take care of the limitations with KL divergence. Also, KL divergence is not symmetric in nature, meaning a comparison of version 1 to version 2 should equal the comparison of version 2 with version 1. So it could be possible for software network to revert back the code changes due to some production issues on minor release, and at that time the comparison should reflect the asymmetric property which portrait divergence exhibits. So this slide is just about how the portrait divergence is calculated. The KL divergence is one of the famous methods that is used to compare portrait distribution, and then the portrait divergence basically overcomes the limitations of KL divergence, and it basically appropriately fits for the software networks. Now, the way we introduce the network portrait divergence, there are other 20 plus other software metrics that are calculated at the class level. So I built a tooling around it. So for example, like for CK suite, Maccabe's cyclomatic complexity, and other basic CK suite, there are different libraries available. So I built some of the tooling around it. I used some of the open source Java libraries, and then I added the network portrait divergence value to it. So overall, I built a tooling to calculate these software metrics, and then also I use defect data sets to capture the defect information. I use for my analysis purpose, I use 29 plus different software projects, and these are some of the results. This is the example of Ant software. We found that network portrait divergence can measure the changes between software releases efficiently. The table that you see here shows the Ant release metrics and its color-coded network portrait divergence. A higher number means that version change a lot structurally. The 0 means that the two releases are exactly the same. The highest portrait value is coded in red and the least in the green, and the remainder of the number would have the gradient color. We note that the two most different releases, the most changes happened between version 1.6 and 1.7. You would see that I plotted the nodes, edges, and the path, and also the average degree, diameter, and the clustering coefficient. So we see that the most changes happen in between 1.6 and 1.7. These are the one where there is a sharp drop in number of execution path. But again, in release, not only ported divergence could quantify the code change, but also it identify the changes as well. So we identify that at the software level, it would identify the structural changes and it would quantify that, and we could use that to for the metric comparison at the software level. Now I move my focus from software level to class level. Here is a small example where this is a simple Java application, and the boundaries basically say that these are different classes within the Java project. We calculate the ported divergence at the software level. The value came to be 0.186, but when I calculated the value at the class level, it came to be different. It's just because that the whenever the code change happens, if you add a new function, then uh, then the then there is the overall impact to the software level, but each class may not have the same level of impact, just because the particular classes may not have much connectivity or may not have major impact with respect to the change happen. So that's where we use the ported divergence at the class level, because sometimes whenever change happen, then one class which is not related to the other class may not be impacted by it. So that's why the objective is to identify the impact at the class level, and that's how we achieve it using the metric. So after that, what we did was we compare the metrics performance with the other software metrics available at the class level. We see that here the NPD exhibits a so NPD is here in this row, the blue one highlighted. So NPD exhibits a weak correlation between the LOC, RFC, and CBO, which are the class level metrics. And on the right hand side, you would see that this is a kernel density estimation plots. It is a well-established statistic method for studying the distribution data characteristics that yields a continuous function, and that estimates the data's density distribution. We also see that the portrait is positively correlated with RFC, CE, LOC, and CPO. The NPD also has a negative correlation with CAM, and yeah, what we see is that the metrics where it has the correlation are basically the metrics which are built through counting the subpaths of length 1. So that's why we see that the other software metrics, RFC, CE, LOC, CBO, are closely related to NPD. Now, after that, what we did was we identified that the matrix is useful and it's correlating with the bug. Then we try to take few examples within the code base and see if it's really helping or not. So this is one example, class and structure. we see that the class and structure basically underwent significant changes. If you see that it had like 12 edges in 1.6, now it has 4 edges. It was a part of 15 execution paths, and now it's part of 6 execution paths. So we went to the core and we saw that the ant structure class was split into 3 additional classes at version 1.7, and all of its connection to other classes were rewired. We see that in this particular instance, the RFC and LOC correctly identifies the changes, like you see the bump. But along with that, even the network ported divergence is also changed by a margin. Similarly, we identify, even in the example of class delete, what happened is that the class delete code base has been steadily growing with each software release, and it has become a component of numerous execution paths. You see that it was a part of 97 paths, 125 paths, and then at this moment you see that it's part of a 78 paths, which is roughly equivalent to version 1.4. So what we see happened is that this behavior indicates that the class is not doing too many. I mean, what happened is that at one point the class was doing too many things, but after that, in the next version, it's not doing too many things, and all of the metrics correctly reflect the changes, and even NPD shows the same. Similarly, with the other two classes, as you see here, executon and directory scanner, we also see a similar pattern, and this becomes useful that it's able to identify the class level changes, and also its performance is comparable with the other software metrics. So we basically conclude that NPD reveals differences in software network and provides useful information at the class level and software level. Now, as you saw that we introduced the software metric called NPD, we check its usefulness at the software level, at the class level. Now, as we collected so much data, now we want to use that data for software defect prediction. If you see that this SE and I have been focusing on, like when I started my research, as I was practitioner, I was more focused on software engineering side of it. And then while doing the research work, I also got introduced to the AI, and then the pieces, it's like machine learning and deep learning. So overall, what I did was I did the research for SE for AI, where adding the software engineering processes to AI based development, and also use building AI tools for software engineering domain. So that's have been my focus. So in this particular objective, I basically built a software defect prediction model using the software metrics and the network coded divergence. The approach remains pretty much the same, but what I do is additional thing is that once I collect the class level metrics, I also add a defect dataset data to it. So this promised defect dataset is kind of prominent in the software defect prediction domain. It has a number of Java projects that I can use for the defect prediction. So what I did is that I calculated the metrics at the class level. I add another column which is basically the number of defects, and then I did some class level metric analysis, followed by building the defect prediction model. I mean, at the objective one, I basically already had a pipeline to pipeline set up to calculate software metrics at the software and class level. So we basically use the software. We basically moved our focus to software defect prediction, which will basically predict the number of software defect, or it would predict the binary defective or non-defective at the class level. So yeah, this is the approach. I also did some literature review about different defect prediction strategies. Some more about what are the newer metrics that are used, or are there any new strategies in AI, or if there are some other approaches that have been performing better than the state of the art. So in this particular solution, what I did was I also did some metric analysis with respect to SDP, which is software defect prediction. I also saw some examples at the class level, and then we built the model. So this is a snippet of CSV file of the data set. You may not see this clearly, but this is at the class level. You have the class name, you have the version name, and then you have all the 21 metrics and defect or number of defects, or the defective or not defective field. We also see that some analysis that was done in 2019, they also use similar number of software metrics. Like this was a review paper where they saw that 9 or more different research papers use similar set of software metrics, which I have used in the paper. In this particular work, I use 9 projects. I mean, if you have observed, like previously I mentioned like 29 plus project, and now I'm mentioning 9. It's just because it's hard to get data. It's hard to get defect data, and promised data set and some other available data set had limitations on number of projects. So that's why I settled on 9 projects where I had the defect data available. You see the number of versions I used, number of classes, and the number of defects each of them had. These are kind of low, medium, high range software projects. If you are writing research paper, yeah, like sometimes you might need to mention your rationale behind it, like why you selected specific projects. So yeah, I also have that in another slide. So the software defect prediction. So software predictive models mainly use supervised learning techniques, which require large amount of data to train a reliable model. However, if there is no or insufficient past data for a particular software application, then training set can be modeled using external projects, external projects with known defect information. This is called as a cross-project defect prediction. So if I don't have sufficient data for my current project, I would use data from some outside project, and that's where the concept of cross-project defect prediction comes into the picture, CPDP. And then if you have sufficient defect data from your prior releases, then you don't need to fetch data from outside project, and you would call it as a within project defect prediction. We also compared our work with a model with these 3 state-of-the-art approaches, which all provides predictions of the number of defects in software modules. And second, to the best of our knowledge, these approaches have been reported to be more accurate than the other related approaches. Now, yeah. So now, as I said, like we set our data set. We use a specific projects where defect data was available. we target the CPDP, WPDP, and also we have this classification problem and regression problem. Classification meaning the class could be defective or not defective, and regression meaning we can predict the number of defects. Now I will go to the results. In the results, I did some metric analysis. Building a predictive model basically requires several features, and we find that these are the top 10 software metrics out of the 21 metric that I showed in the CSV. So the ANOVA test is used here. ANOVA test basically select a feature with the most significant relationship with output. So we see that portrait is at number 6. Then we also did some analysis, some univariate analysis. We could see that portrait has been performing well for classification problem, as you can see here in this slide. After, so like now here I set up the stage that hey, these metrics are analyzed using ANOVA test. We also did the metric analysis for each of the scenarios. After that, I build a deep learning model. To assess the performance of our model, we use the measure F1 for the classification. And as you can see, we use a same model for the classification task and for the regression task. We use the F1 for classification evaluation, and then we use MAC and R-square for the regression task. F1 score basically transmits the balance between the precision and the recall of the model. For example, given a highly imbalanced dataset where number of bug-free classes is much higher than the number of bug classes, a model can predict only a class 0, meaning no bug, and still achieve higher accuracy, sometimes even in 90% range. Therefore, instead of using the accuracy portion, we use the F1 score, which provides a much more accurate evaluation for the prediction model. Our defect classification and model evaluation produce overall accuracy of 94% and F1 score of 0.76. We also show the confusion metrics as well. For the classification model, we use the binary cross entropy loss function with logits and the Adam optimizer with the default value of 1 10 power -3. And for the regression model, we use the loss smooth function L1 that uses square term if the absolute element wise error goes below 1. So that's after that. So these are the results for the regression. We see that the proposed approach achieves better results compared with other state-of-the-art approaches. Our method improves the state-of-the-art approaches by 18% in terms of MSE and 48% in terms of R-square. Typically, low MSE and high R-square are desirable. These are some of the execution times that it takes, like the system that we built. We ran the experiments on 2.3 gigahertz quad-core CPU with 16 gig of RAM. We see that on average, it takes like 7 to 8 seconds per class, and like on average it takes around 40 seconds per KLOC, which is basically still higher. But again, in our next version, we probably improve the numbers by some parallel processing around, and even also with the computer with high configuration, yeah, these numbers would definitely improve. So now coming back to the conclusion, so NPD is kind of proven suitable for SDP, software defect prediction. We compared other metrics and then trained the deep learning model, which basically perform better than other state-of-the-art approaches. Do we have any questions so far at the moment? Anything? Any clarification or anything?
No, maybe you finish our
Okay,
presentation
sure.
first.
Okay. Okay, sure. Thanks. Okay, now, yeah, so we finish our objective 1, objective 2. Now, so like in objective 1, we set our pipeline to calculate the metrics. We compared, we calculated the new software metrics, network ported divergence. At the software level, we calculate at the class level. We see that it's effective at the software level. We saw that it's effective at the class level, and now the data that we collected as a part of it, so that data so using that data, I build a public bug data set with the metric in it, new metric in it, and I evaluated the bug data set for software defect prediction. Now my pipeline of setting up the project remain the same. So like whenever if you are starting your research, usually you build some pipeline, and once you build a pipeline, you basically have a strong framework which is ready, that you can use that framework to come up with new set of like use those setup to solve new set of problems. So what we did is we built a data set of 21 software metrics at a class level, and then check if the data set is fit for SDP or not. Researchers have been probing through popular data sets such as the Promise, MDP, and some other data set which are built on top of it, such as the Bug Hunter and GitHub Bug dataset. Now, only a few datasets have been foundation for the further research from too many datasets. The problem is that some datasets are not publicly available, some lack reproducibility, and some are incomplete. What we did is we used this information theory based metric called network ported divergence, which has been proven useful for SDP. And then we also add that metric to this newer data set. Some of the literature review I did was as I mentioned that we already had a pipeline. We added new projects. We find that all of the metrics are also part of the recent dataset approaches. So these are like some existing datasets like Bug Hunter, GitHub public dataset, Promise MDP, and NASA datasets. They had like their own pros, but some of them had the cons as well. Some of the datasets are not extendable, so meaning you cannot add new projects in it. Some of them did not have jar files available. Some of them obviously they did not have a path-based metrics available. And what we try to do is in our approach, we try to solve these cons and build the public bug data sets. So as I showed in the previously as well in the objective 2, this is the CSV snippet. We find that all of the metrics that we use are part of the recent SDP approaches. As I mentioned previously, I think some of the rationale that you can put whenever you select any projects for the any of the task, you could basically mention why you selected specific projects. So why I selected those projects was because in all of the work I wanted these projects to use some source control. I wanted them to be using Java because all of the tooling is around Java. We want their defect data to be available. We also wanted this to be kind of at least 2 years old, meaning it has a sufficient development history, meaning at least there is a group of people who is actively contributing to the project. Also, we wanted these projects to be accepted by the community, so that because we also didn't want to build our tooling, build this data set using some proof of concept projects. So we just want the application to be accepted by the community. And also we wanted the project to be have a reasonable size. So yeah, so this is some of the rationale behind selecting these projects. After building this data set, I also mentioned these 12 different machine learning algorithms. You can I use a tooling called Weka. Now the good part about this Weka tooling is that you can pass a CSV and do some configurations, and it would run the machine learning model, and it would basically give you some statistics that you can use. So now I will go to the results. So first result like that we compared the datasets and found that GraphView has most classes in 9 projects. We for some of the projects, what happened is that we could not find entire Java binary files so that we can compare them with each other. The problem is that some of the existing tooling in Objective 3 was based on jar files instead of the actual source code. So that's kind of a limitation of the tooling that I built. I overcome that tooling thing in my Objective 4, but again, till Objective 3, I had that limitation. So because of that, I had a less number of projects in some other projects where defect data was available, but I was not able to use it. Also, it is also worth noting that while Bug Hunter and GraphEvo have 6-month limits, some of the projects basically restricted the project to have a 6-month limit as well. Now, what I did is after that we did some feature importance analysis. We performed that on all of the investigated projects. We find that the LOC, the CAM, LOC, RSC are most influential metric, and even NPD is also influential. Then the 12 machine learning algorithm that I showed, we out of those 12, we basically make a list of top 5 performing one. So here is the list of top 5 machine learning algorithms along with their F major and AUC value. We see that F major values vary greatly among projects for several reasons, like number of versions, code base size, defects. To take for example, like the ant, the ant and the broadleaf commerce project. The ant is one of the largest project, while broadleaf is kind of middle level. Ant contains 2078 class level entries, but broadleaf has 2972, making it more suitable for usage as a training. The best algorithm that are found in the bug hunter were simple logistic, decision table, SGD, logistic, and J48. We and even the same result we saw in the GitHub bug dataset. we found that random forest have worked well for us. And whenever someone is doing any software defect prediction related activity, could basically use random forest at the as it could give results for someone else as well who is doing the research. Now we also compare the number of entries in the F major, the average F major, the minimum and maximum as well. The number of entries in each data set varies, but they all include a sufficient number of entries as well. So at the end of it, objective 3, we conclude that GraphEO dataset is relevant for HTTP. It's utilizing the ML approaches, and it could improve the existing methodology. Even the tooling is available on the GitHub. I mean, all of the objective 1, 2, 3, all of the tooling is available on the GitHub, and it could be used to add new projects as well. Now, coming back to objective, so now as we focus on the characterizing the software at the software level, at the class level, and then we build a bug data set. Following that, we basically go one more level granular at the pull request level. What we do here is that we analyze the code changes, and also we comment on a company test for better software quality. So as you can see, this is a typical GitHub. This is a typical GitHub project. This is for the software end. You would see that whenever whenever a developer begins their work, they would basically create a new branch from master. They will basically check out a newly created branch. Then they will create and push they will work on their feature, and then they will push their commit. If everything is all right, they basically create a pull request. Now this pull request needs to be reviewed and merged, and then again developer would go back to master. So this is a screenshot of a typical pull request review process. You would see, I'm not sure how much you can see, but there is a conversation that happens between the developer and the lead, or like the one who are managing the source code. So they would have their conversation going on. You would see that number one has created this pull request. Number one does some comments, and then number two reviews it. Number one replies to it, and I think at the end of it they would talk, and at the end of it the pull request would be ready to get merged. So it basically involves some back and forth conversation. It's similar to the research community. Whenever we submit to any conference or journal, you basically get a feedback. And then you might get minor revision, major revision, or you might, if you are lucky, you'd get accepted right away. So sometimes, so like the same thing applies even to the pull request review. The reviewer may have some feedback, and usually they have feedback. I mean, I review so many pull requests every day, and I always have some bias as well with the developer because of the prior experience. But it's hard to review the pull request with full unbiased nature. It's hard, but I think that's where the software engineering research community, the community basically comes into the picture, and build a tooling around so that the pull request review process can be improved. So how do we do that? The typical pull request review process would look like this, where The developer who is working on it will fork and clone the project. They will modify the code and submit a pull request. Now the pull request would go through a code review. If the reviewer feels good about the pull request, it will accept. The code gets merged, and then we close the pull request. If the reviewer is not happy with the pull request and suggests some changes, then the code is revised, and then it goes into this cycle, and then once it gets out of the cycle, as I accept, the pull request can be closed. Sometimes sometimes the pull requests are rejected as well, but again, mostly these are kind of stale pull requests, and you might have a similar pull request which is covering it. Now, what happens is that this pull request review process happens in kind of async nature, where developer might have work on it, then the reviewer is busy. When a reviewer gets time, developer is already has finished his day, or might be doing some other task. And sometimes developers are scared to ask for approving the pull request, because it just kind of reviewer would judge their work. So what the research has shown is there is a company called Linear B. They studied 733,000 pull requests, and they also studied like 3.9 million comments. They found that 50% of pull requests were idle for 50% of the time. So meaning there is no activity on that pull request. It just sitting there. 33% of the pull requests were idle for 77% of the time. So also average cycle time for the pull request review is was 6 days, and average pull request review time is 4 days. So basically it takes some time for the pull request review. It could be that the work is complicated, or it could be that the reviewer might need to spend more time. So yeah, there could be so many reasons, but these are all stats that we have, that it's difficult process. Now, how we could help is that there are some tooling about again, these pull request review process are also important for the organization, because it gives them a timely mentoring opportunity. So there is no better time to mentor a new member than when they have just written some code and it's still fresh on their mind. Also, it keeps the master branch pristine, meaning the teams would always run their automated test against the PR before the merge. This guarantees that the test on the main line always pass, and it's basically keep your software in pristine condition. Also, as a PR provides a natural time to review the code quality, a post-merge review means there is at least a small time when low quality code leaves in the main line. So yeah, so the point is that it improves your code quality. Also, these are kind of manual checks, and I think some manual checks would happen in the workflow, because imagine like it's million it's your company building the software that impacts millions of lives. Then yeah, I mean, you have to be pretty sure about whatever the code changes that you make. So yeah, there would be some manual checks. But again, how we can improve this process, all right? So there are some ways that it could be improved, like we can give the feedback as immediate as possible. Then then a developer should be able to complete the task with minimal interruption. The process should be simple to execute, and it should make no assumption about the seniority of the team member. So yeah, I think I face the item for all the time, that that like people, whenever they raise the pull request, it could happen that you like developers would get scrutinized more if they are early in their career. Now, what are the alternatives to PR, right? So there are, like, people can do some pair programming, meaning whenever you have some work item, you basically have two developers who are working on that code. And during that session, basically at the end of the session, you would have your code complete. Now, at that point, there is no code review required because both the developers work together. Second, it could be a periodic review where you don't review everything, but you just do that on periodic basis. Sometimes you can use something called the pipeline approval, meaning you would basically merge all the changes, but you would review only when you are doing the deployment. So yeah, so I think there are different alternative ways as well for the PR, but our work would basically focus on using software metrics to improve pull request review process. So some of the literature review that I did as a part of it, that change with there is a Microsoft base application as well. There is the pool based space dataset as well. All of these applications were publicly available, like some of them were publicly available, and then some of them did not have any software metrics involved. So we basically, as a part of the work, we identified the cons, and then we added the software metrics and visualization piece to our solution. So yeah, here I will go to the solution. So we built a tooling, we collected the PR data, we also analyzed some interesting cases and some of the user study that we did as a part of it. So yeah, so the approach, as I said, the approach remains similar, but again, instead of passing Java projects, I'm passing a pull request to my pipeline. I calculate the metrics, and then I show the analysis at the pull request level. So the pull request typically consists of this function where F1 through Fn and FF1, FF2, FFm. So where F1 through Fn are the source code file pre-PR, and FF1 and FFm are the source code file post-PR. Each of them would have classes as well. For this work, I use 14 software projects and like totaling around 600 plus pull requests I use. What I found was that these are some examples where we did some manual analysis, and some of the manual analysis indicated that the changes reflect the execution path changes, and we find that the changes happening in the NPD are kind of reflecting more structural changes. What we also did was, along with the code change, we also observed the items, the changes at the test level as well. We also provided the utility of the UI, and then we also showed the metrics at the class level. Then followed by that, we did a user study. Yeah. So this user study. So this user study basically involved we evaluate the usefulness and usability of our approach and the tool, making using this user study. We involved 24 participants who carried out a set of tasks and then answered a questionnaire. The questionnaire included 5 questions to assess the usefulness of the tool and 3 questions to assess the usability of the system. These were the questions, and it had a it used some four plus other cases as well as a part of it. So we found that by and large, people find that it's useful and usable as well. But we also saw that like some comment that we received was the tool is helpful in review the pull requests rather than doing it manually. The call graph visualization is helpful to identify the overall impact on structure. This tool could help save time and efforts in pull request review. Some of them mentioned, I believe the tool will help and save time. Some were concerned that if the code base is large and if the pull requests have complicated pieces, then it may not work. Some mentioned that there could be more data, and we agree with that. But again, it's hard to collect the data. Some mentioned that with the tool, the help with different versions of Java, they were kind of very particular about a specific Java version support. Some basically ask about, can we include additional statement coverage, branch coverage, adding some testing framework to it, and some good feature that can enhance it. So overall, at this stage, we conclude that the tooling that we built for pull request can basically improve the pull request review process and help speed up the pull request review. So in all of the work, basically there are some threats to validity as well. The code changes, like as I said, like we use call graph, so the code changes within the functions are not accounted as we just look the software at the structural level. Then static call graph may not cover all the paths within the call graph, and its union with dynamic call graph may improve the findings. We also use that defect information as it is. SGZ is the typical algorithm that is used for the defect mapping, and recently there have been some improved version of SGZ, and I think that can affect the overall results. Now, software programs from different domains may produce different results. We use one static code analyzer. Using multiple static code analyzer can also produce different results. Tooling for for our first 3 objectives, the tooling was built on Java binary files, which are the jar files. But again, for the objective 4, we improved that, and we have the tooling which can take the source code. So along with that, I mean, with this objective 1, 2, 3, 4, supporting the software analytics piece at the software level, class level, bug data set, and at the pull request level. Some of the future work that I see that as this work focus on Java, I could add support for other programming languages. C# should be ideal to onboard. And it's similar nature with Java. Then even Python could be used as Python is getting more traction. Also, I use software metrics, like 21 software metrics for software defect prediction. I could also use, and then I use basically a deep learning model as well. So I think the next stage, like graphical neural network based model, could also be used. I can just take the whole call graph and pass that to the model through some embeddings. I could also build a bot that can do the pull request review. I also wish to apply the work to software vulnerability as well. And then, yeah, I think this is pretty much about the presentation. Thank you again, and all of the questions are welcome. All of my work is available on the GitHub. All of these links, and yeah. Does anyone have any question? Thank you. Thank you for listening. Thank you.
Thank you very much, Dr. Vijay, for your great and valuable knowledge sharing about GraphInfo, and I think it's the building block of GraphInfo, right? You
Yes.
spared it in several sections in
Yes.
this presentation. So
Yes.
all participants, may we give a big applause for Dr. Vijay.
Thank you.
Thank you very much. And then now we are going to proceed to the second agenda, the question and answer. And one, two, three, four. There are 4 questions from participant, and question
That's great. That's great.
number 1 is from Mrs. Rismi. In machine learning, we usually classify based on feature. In this case, logically, how can we use machine learning or deep learning to classify faulty software? Is there any specific feature or relation?
Yes, I think that's a great question. So yeah, we usually classify based on a feature. The way I started the work was that we were looking at the software metrics, and that's why like the metrics became my feature. But again, I could cluster some of the metrics and build a feature, and then compare and then build a model around the features, which would be a group of metrics. That's a great question.
So basically, the what is may this specific well, how to consider that this is really metric for faulty software?
Yes, that's correct. That's correct. That's
okay.
Correct. Can we work with that?
Okay.
Yeah.
Okay,
so
we go to the next question.
Yeah.
Can we work with GraphInfo in architectural level or component level?
Yeah, that's a great question. So that's one of the work that I'm currently working on. Yeah. Basically, you have this call graph which shows the functions, and then you can build a class diagram, and then if you cluster that, you basically get the community structure, which could show the component, and you could basically identify the component level change, like basically you can show the component interaction and then identify the changes to the component interaction as well. So yeah, that's a logical next step.
Okay, well, thank you very much. And we know that a component contains from several classes, and then you may work the component interaction instead of interaction between classes.
Yes, that's correct. That's correct. So yeah, I mean, again, like again, there would be some boundaries of the classes, and when you kind of cluster the call graph, you would get the communities, and those individual communities would nothing be but the actual components, and there would be some boundary. There would be some connections between those components, and yeah, we can definitely compare the component level diagrams, and yeah, you can see the evolution from the components perspective. And
I think it's important if you work for the component, because some software like JUnit from JUnit 3, JUnit 4 and 5, there's it's significant differences between each version, especially in component level.
Yeah, sure. Perfect. Yes, that's. I mean, it's again, like all of the research work. I mean, the major problem is that the whenever you download some GitHub project from online, it's hard to set up that particular project on your own computer. It's it becomes crazy, and yeah, you have to have different Java version. So
Yes.
yeah, good luck everyone on doing that, but yeah, it takes some efforts. Yeah.
Okay. And the next question is related to what is the next development of
Next
Graph Info? Maybe you
yeah
may detail the next
yeah
development,
I'm
the further
yeah
development.
I'm sure yeah I'm currently, I mean, as I said, I'm working on a graph neural network based software defect prediction, and I also have another project on the architecture side. So yeah, these are the two things that I've been focusing on.
And okay. And another question is from Mr. Ade Setya. Is it possible to implement defect prediction in to non-Java based project like PHP or C#? If can,
Okay.
is there any adjustment needed?
Yeah. Perfect. That's a good question. So yeah, I mean the idea of the network ported divergence is around call graph and graph structure. So all of the, like, C sharp is obviously object-oriented programming languages similar to Java. So for that, there would be no adjustment needed. But again, some of the languages which were, I mean, even Python, it was initially started as a procedure oriented, but even Python has object oriented features. So yeah, some tweaks are needed, but again, all of the languages would have some abstract syntax tree or a call graph like structure. I mean, all the languages will have. So at least the network ported divergence piece, that where the actual software metric calculation is will not change at all. It's just that the procedure oriented languages may have some different software metrics, and which are basically not available in the object oriented one. So yeah, it's just the change on that side. Other than that, yeah, it should be similar.
Okay, like Java and C# is almost similar, right? For name,
Sure. That's it for
there's namespaces, and C# has namespace, and
sure.
Java has package, and both have almost several similar class declaration, like.
Sure. Yes. That's correct. That's correct. I mean, I'm a C sharp developer in Office, and
Okay.
I build a C sharp based tooling, and in the research, I'm using Java. Java is the choice because you would find so much content on Java online when compared with other languages. So.
Okay, you also VP.NET developer, right?
I mean,
Okay.
I had a, like, in my role at H&R Block, basically we had our code written in VB.NET. Then we had our test suite, which was written in C sharp. And like every time when I make a
Yes.
code change, I have to do the thing in two languages. Yeah, so that's fun.
Yes, that's fun.
Uh,
Okay.
yeah.
Oh, there is more question from Mr. Malik. Can Graph Info be used to show the evolution of software architecture?
Okay, this is again. I think we covered the software component piece, but again, with software architecture, the again we have like many moving pieces involved. Recently, I have been reading about something called as a C4 model. Okay, C4 model, which talks about representing the software in by graphical way. So there are C4s, like C is a context, then there is a container, then there is a component, and then there is a class. So there are like, so these called as the C4 models.
C4 model. Yes.
So C4 models. So now these are basically pretty much popular now in the software development phase. I think it's just 2-3 years now. They are kind of talking about it. So with these C4 models, I can represent the software, and then it would also have the software in terms of, it will also depict the software architecture as well. So what I'm seeing is that if I take that C4 model and then calculate these metrics, I think I could capture the evolution at the software architecture level as well. So if anyone is starting their work, yeah, just take a look at the C4 models.
So the next development of Graph Evo is the use of C4 model, like.
Yeah, that's what I've been focusing on. Yes,
Okay.
yes.
The next
Meaning of
question
model.
is from Naufal Zaki. How the modularity was calculated and what is the meaning of each result value?
Yeah, so the modularity meaning how the nodes tend to cluster with each other, right? So if you have many communities within the source code, then it would basically mean that it is highly modular. So yeah, we want these to be modular in nature. I mean, there's something called the high cohesion, low coupling. So yeah, we want these models to be lowly coupled with each other, but yeah, the modularity should be high. That's what is expected.
I think this is based on your presentation in section 2, maybe the
Yeah,
modularity.
sure. Yes.
Modularity. Okay. And okay. The next question from Sandi Kurniawan. Does Graphivo use open source libraries in it? If so, what is it used for?
Great. So yeah, I have used so like as you have seen, I have like total 21 software metrics. So all of these 21, I mean initially, these 21 metrics are at the class level, and then we have like 6 metrics at the software level. So software level metrics are kind of I did calculated manually, but again if you are using Python for the tooling development. So like what happened is the project I have used are all Java based, and then the tooling that is used, the all of the tooling is built using Python. Okay, why Python? Because it's easy to add new stuff, and it's faster to market. So I have used different graph libraries in Python, and also to calculate these Java-based metrics, I have used CK-Suite metric library, CKJM library, extended CK-Suite library, and for the network ported divergence calculation, also I have used an open source available library. So yeah, it's all open source. Also for the UI, there is something called the graph weeds, so UI that you can use for the UI purposes as well. So yeah, it's all open source.
Okay, thank you, Dr. Vijay. It is almost the same question as before. Can we work together in architecture?
Yeah, sure.
Metrics. Oh, what metric software do you use in Graph Evo? Do you create your own metrics for Graph?
Yes, that's correct. Yeah,
Your own
perfect. Yes, sure. So yeah, the thing is that, as I said, I showed the problem with networks comparison. I showed the known network and unknown network problem. So in the unknown network domain, where number of node would be different in the first version and second version. So in that unknown network problem, there was a research that was done in 2019 and 2022. 20 to calculate the network portrait divergence that was created as a metric for a general network comparison purpose. So the new thing that I did was I applied this available metric to software problem, and I applied that at the software level. Then I modified the metric so that I can calculate the metric at the class level. So it basically involved assigning more weightage to the class for which we are doing the calculation and giving low weightage to the other classes, and then repeating the same step for all the classes. So through that, I calculated the metric for my problem. So yeah, it's my metric at the class level. Yes. Okay,
Okay,
GitHub.
and it is interesting. I think. Could you please show the slide that compare the unknown and known graph?
Oh yeah, sure. Let me share again.
In section
Share.
2, if I think.
Yeah, this one.
Yes, this one. So you compare the unknown and known network. Is it right?
Yeah. So
Is it right?
yes. So
Yes.
basically, if you are going to compare two networks, right? So whenever you compare two networks, you would have your problem, which would be in one of the category. It could be that your number of nodes will not change in network 1 to network 2, or the number of nodes would change from network 1 to network 2. So yeah, this is the known network correspondence and unknown network correspondence problem. So for each of the problem set, I saw what are the best available distance comparison metrics. And then I check that software network problem is of the category UNC. And then I see what are the top software metrics, top network comparison metrics in the UNC domain. And that's where I came to know about network portrait divergence, about its performance. Does that help?
The interesting question is how to extract the characteristic of unknown network.
Oh yeah, sure. So for example, let's say you have a, let's say you are driving from, let's say you have a network of airports, right? So so let's say tomorrow, if you want to see how the airline network is performing from last year to this year. So you would basically have two graphs, one showing the airlines in 2021 and one showing in 2022. You might find that you had less flights in 2021 and you would see more flights in 2022. But the number of airports remain the same. Okay, that's where it's called as the known network problem. Now, similar case, let's say you have your LinkedIn graph. Okay, LinkedIn graph. So in the LinkedIn, you have your connections, right? Level 1 connection, level 2 connection, level 3 connection. So in the LinkedIn world, you have, let's say if you plot the graph in 2021 and in 2022, you may have new people join to your network. Some might have left the network or something. So the nodes that are involved are changed in unknown network correspondence problem. But in the known network correspondence, the number of nodes remain the same. So software networks is a problem of unknown network correspondence. And once I figured that out, I check the distances that are performing well for this category, and then I use the one for my problem. I applied that at the software level, and then I modified it so that it would work at the class level. So yeah, that's the part of it.
Okay, nice explanation. But we can conclude that we doesn't only count the node but also the distance between node. Yes.
Yes, that's correct. That's correct. That's correct.
Okay. Is there any question? Any more? Some more question? Wait. The next question is from. Wait a minute. Wait a minute. I have lost my chat. Yes. Where can we download Graph Evo? Okay,
Yeah.
this is the positive one is still interesting. What Graph
Yeah,
Evo?
yeah. So yeah, I have all of the work available in the GitHub. As you can see the links here. If you look out for my name, you would also, one second. You could also see my website. At vijayvalunj.com. You could also see my research gate, and you could also see my Google Scholar, and all of the papers also have the link to the GitHub. Yeah.
Okay, thank you very much, Dr. Vijay, and I should add you in my LinkedIn.
Yeah, sure. Sure. That's
Okay,
no
okay.
problem. And yeah, and if anyone have like any collaboration ideas or any
Okay,
other thing, yeah,
that's
feel
good.
free to work on. Yeah, I think I'm even after graduating, yeah, I think this is I think even if you are working in corporate and writing code, yeah, I think research is good. It keeps you motivated, and it's kind of, that's where the difference
Mm.
comes between other developers and yourself when you have your scientific approach to any problem. So yeah.
Yeah, sure. Several of my students do several software analytics, and it use some several metric you mentioned in your presentation.
Yeah, sure.
Maybe we.
Thank you very much. Thank you.
Another question from Mr. Adi Wibowo. Could you explain more in detail how graph construction process? There is any problem issue that should be solved in?
Oh yeah, so okay, 1 second. What is there any problem issue? Okay, so basically the graph construction process is happens through this is called as a static call graph. Okay, meaning there are some libraries, open source libraries, which will take the source code, and it will try to traverse from the entry point to the all of the edges. Okay, so there is a graph construction. There is a different field altogether which focuses on graph construction. So static code analyzers are typically used. As again, my research was mostly focused on the analytics part of it. I have used the static code analyzers directly without going into much detail. The only information which I have is that these static code analyzers are, as again, Java has been so popular for so many decades and is in practice for more like all these decades. So the static code analyzing tools are kind of state of the art in nature, as I can say, and and but again, sometimes what happens is that there is a another field called as the dynamic call graph generation. uh, like the static call graph will not consider any data. It will just plainly build the graph. But if you use dynamic call graph, you could provide some data, and through that data you could traverse more path which were not covered in the static call graph flow. So yeah, so if you use static and dynamic both, your data could improve by a lot. I mean, I had a similar question in my one of the journal paper review, but the thing is that as I already built a tooling around static, I was in kind of time crunch about adding new tooling to it. But whatever I read was that even if I add dynamic, it would improve my performance by a bit, but again it will not drastically gonna change my results. So that's what kind of I came to the conclusion, and was able to bypass the question in the journal paper review. So yeah, similar thing you could also do, but yeah, if I want to begin my research again, I could have the tooling that could take the two, both of them. Thanks for the question.
Okay, there's some more question from Mr. Ativipo. Do you have any suggestion which book or paper or tutorial that could start for reading to be
Graph
more
construction.
understand how graph construction for feature extraction? Maybe he is field research field in machine learning for feature
Yeah, I think
extraction. Yes.
tutorial. I mean, I'm not thinking. I'm not able to recall anything on top of my head, but I would say I think GitHub has so much content.
Okay, GitHub.
Okay, GitHub is the best. I mean, what I have been. I mean, again, get on GitHub, you would find all kind of repos with so many things in it. And for the graph construction, I think there are many static call graph analyzer. You could read one of my paper and you would see I have also cited the tools that I have used. So you could find a couple of the tools in the graph construction. And yeah, so yeah, you could use that as a reference. And then yeah, that's pretty much about it. Also, I would say if you are looking for something, try to frame your question correctly and then put that to Twitter. Okay, even you get good responses on Twitter as well. So yeah, Twitter is also good source to get the answer.
Okay. Okay. Mr. Ativipo, any other question from this discussion? Explain the, because the interesting part is, I think, how to generate color and collie graph and then measure the distance, and then
Right.
we
Yeah, I think
yeah. Okay.
I mean, I think maybe Prajanto, I can just reply you or LinkedIn and just give
Okay.
you the
Yes.
detailed thing, and then you can share that with the group. Okay.
Okay. I think and now it is some more. Is there any more question? No.
No.
And we have 5 minutes left in this session.
Okay.
Okay. I think this is a nice discussion, and we can continue in our LinkedIn account on or in email, right?
Sure.
Okay. I think this is actually we would like to have some deep discussion about software evolution, but unfortunately we have come to the end of this session. Thank you very much. So once again, thanks Dr. Vijay for great and valuable knowledge sharing today. All participants may we give big applause to our distinguished visiting lecturer today, Dr. Vijay Walunj.
Okay, thank you. Yeah.
On behalf of moderator in this session, I apologize if there is any mistake in guiding the session. Once again, thank you very much and see you again in the next opportunity. Wassalamualaikum warahmatullahi wabarakatuh. Back to you, Felia.
Thank you. Good day. Thank you, guys.
Thank you.
Okay, thank you, Mr. Vijaj Walunj, Ph.D. and Mr. Panji Wisnuwirawan, STMT. Before we move on to the next session, we are going to do a short photo session for documentation. Taking a picture on my mark, 3, 2, 1. Okay, thank you very much. Once again, thank you very much, Mr.
Thank
Vijaj
you.
Walunj, Ph.D.
Thank you. Thank you.
Distinguished guests, ladies and gentlemen, we are proceeding to the second lecture of today's visiting lecturer. For this session, we are very honored to have Mr. Khairul Answar, Ph.D., the Vice President of DBS Bank. And the moderator for the second session is our very own researcher, Mr. Edi Suharto, STMcom. Without further ado, please welcome Mr. Khairul Answar, Ph.D. and Mr. Edi Suharto, STMcom.
Is my voice okay?
Yes, we can hear you clearly.
Okay, thank you very much. Right, good morning, ladies and gentlemen. I'm Eddie. I'll be serving you as moderator for this second session in visiting lecture. Good morning, Mr. Khairul Answar.
Ya, good morning.
Yeah.
Assalamualaikum warahmatullahi wabarakatuh.
Salam rahmatullah. Thank you for your coming, and we are happy to have you here, right? All right. Beforehand, I would like to introduce Mr. Khairul Answar, PhD, a brief. Yeah, he took excellent educational first in Bandung Institute of Technology, majoring in Bachelor of Physics, yeah, Pak. And then he took master and doctoral degrees in University Technical Malaysia, Malacca, where he got his PhD degree, right? And then he's now a Singapore permanent resident and with more than 17 years of experience as software engineer. Right. He got outstanding award. The recent one is first prize in Bank of Singapore Hackathon Challenge 2020. And he has several publications. The recent one is titled Single Source of Serialization in Distributed Database in Future of Information and Communication Conference, FICC 2022. He has a professional Scrum Master certification as well. All right. Without any further ado, let's pay attention to his lecture from Mr. Khairul Answar. The screen is yours.
Okay, so I cannot share my screen. Host still disable my. Okay.
Okay, please.
Host disable participant screen sharing.
Pak Sandi, please make Pak Khairul as co-host.
You may share your screen right now, Mr. Khairul.
Oh yeah, I can.
Okay, now.
So I just share all the screen. What's this? Google Chrome. So everyone can see my
Okay.
screen.
Yeah, it's good now.
Yeah, in today's session, I want to share about microphone app. So I think, heard about microservices for the backend, but maybe only few people knows about the microphone end. So, and then because this is like new things in industry, including in the banking. So we try to share whatever that we have about the microphone end. So this is the content that we want to share. The first one, we want to talk about the user interface in the web application. And then mostly we already know about single page application with the React.js or Vue or Angular. And then I want to address the problem in the current web application development. And that's why we need a micro front end as a solution. And then I have some demo with the most two famous what we call framework or solution or approach. First one is the single SPA. And the second one is about the Webpack 5 with the model federation. So my voice is okay, right? Anyone can have any issue with my voice? Otherwise, I need to increase my
We
voice.
can hear you clearly, Mr. Answar.
Sure. Okay, so I continue. In the user interface for the web application is basically we know about the HTML. So if you open this HTML, for example, just go to the browser. So when we create any HTML, basically what we can do is we just put as an HTML tag, and then we can put the content in between the open and the close tag. So this is a normal, so everyone should know about this. So I no need to go to detail. So the second approach, in order to create a component or element in the web application that a browser can understand and render perfectly, is using a JavaScript. So we are using JavaScript to replace the HTML script, and it makes the page is become dynamically. So it depends on the data that we have or receive from the backend, and then we can just render using a JavaScript. So JavaScript is in the process, they will create a HTML component on the fly based on the what script that we are writing on. And there is some URL also I provide. So I think everyone also know about this one. So you can just try yourself in order to how to create the content dynamically using a JavaScript. And then next, after the people done with JavaScript, and then there is a jQuery to help the development process. And yeah, I think it is taking a lot of help using a jQuery when you develop a web application and I think between 2000 until 2010 or 2014, right? And then since we want to make it better, then there are some framework coming on to in order to handle the web application development much better. The first one, for example, React.js. Of course, there is Angular and there is Vue also, but I just for this example, I just bring the single page application using the React.js. So using the React.js is basically we can just go to this get it started. So either you want to have a TypeScript or a simple JavaScript, and then it will help you to build the boilerplate source code. I have this an example. For example, I just create this my first application using the one that using the so I'm using the npx create template and using TypeScript. So once you're done, it will create this my first app, and then after that you can just do npm start. I think everyone knows about this, but I just want to highlight some important point. So using the React.js, we can creating a web application nicely. And then if you see everything is on, of course, a TypeScript, but it's similar kind of flavor with the JavaScript. So everything is just like HTML, but in the backend, when you do a build, it's basically they convert this kind of React.js component into the JavaScript. So how it is done is basically there is, if you go to the package.json, there is called a Babel. So the Babel will handle all the translation from the React.js kind of component into, let me hide that one, into the HTML JavaScript code. So this is done by the Babel. So if we go to Babel, so we have this Babel. Any component that you write in this, any component that you write in this part, basically it will be translated or it will be compiler. It will be compiled by the Babel into become a JavaScript code like this. So with this one, a browser can execute the JavaScript code and then they can render the content nicely like this. Okay, so what is about the React create element? There are three arguments. The first argument is about the type, the tag type. And the second argument, if you realize it is null, so it's basically it's about the attribute that you pass, for example. So you can create as many as attribute you want. And the third argument is the content or the children. So in the children, you can simply put any simple string, or you can also create a HTML component. So it will be passed as the third argument and then render into the screen nicely. So this is why the React.js become famous, or any other framework also, because it is help to segregate all the code nicely. So you can in the code principle there is called one responsibility, right? So you can create multiple files and then to create their own component, and then you can combine into one particular page. So this is how the Babel translate the HTML like component or React.js component into the JavaScript. So we next, and then yeah, this is about the Babel. So what is the problem with the current state, which is whether it is using Angular or React.js or Vue, is basically if the project is becoming bigger, and for example, I have this on the website. I just open, for example. So we have home, we have profile, we have fakultas, we have layanan, we have pendaftaran, directory, and others. So, and it is become more if we have a lot of menu, and it is become our source code is become bigger and bigger. So just for example, this is only one page. So I have this movie. So in this movie, I have, for example, the container is equivalent to pages. So we have 3 pages, and then pages is we need to maintain into one file, right? So for example, in this movie, I just started. I'll start this one. It's running in 2071. So this is the movie. So if I click this movie, and then it will go to the child, and I click the artist, it will go to the artist, and you back to the movie, back to the movie list. So we have 3 pages, and then you need to maintain. So you can imagine that this page, this HTML page has a lot of pages. So, and then if you want to maintain into one code repository, that we will have some of the problem that any industry also has the same thing. So currently we have 3, and if you can imagine in one pages, full pages, we will have more than maybe 100. So that's why it is very difficult for us in order to proceed with the development. So what are the problems that we face today in the current state of the web application development? Mostly it will have one team, but it's not necessary. Maybe there are 2 teams, 3 teams, depend to the menu, but mostly there will be one team. And then there will be one release schedule. So because we have only one repository, and everyone need to commit to that repository. Since it is commit into one repository, then we only have one release schedule. So either every week or every month or every 2 months or every 3 weeks, all the feature will be released in the same day. And then of course we will have only one build pipeline because it's only one code repository. And then we must use the trend branching model, because for example, I want to release this fakultas in February, I want to release this layanan in April, I want to release this pendaftaran on next month. So since we are only have one repository, then there is no other way or that we can use unless we use to have a release trend model. So what this release trend model is, basically every release you need to create a branch, release branch. For example, you create a March release branch, and all the code related to the March release you need to commit into this March. And then it allows also to others developer to work with for another release, for example, April. So all the code related to the April, you need to merge and you need to commit and merge to the April. So what happened is once this March is done, deploy to the production, if there is some bugs fixed, you need to work on the March release itself. And then don't forget that you need to bring whatever the code from the March into the April. So this is the problem is coming. So when you forget to bring from the March release branch to the April, then when you deploy the April branch to the production, it may lose the March fix. So this one is also happen on the industry nowadays. So if they forget to bring whatever commit that done on the previous month release, we will have a problem on the next month. For example, the button, it should be a red color. And since you forget to bring the commit into the April, then in the April, the button is still in the blue color, for example. So then it become a problem. And then the another problem is the one repository is the source code is become bigger and bigger. So if you see in my linking, I have experience to handle the 245K lines of code, because we only have one repository, and since there's a lot of feature, then we have a lot of lines of files. Of course, we have a lot of files, and since we have a lot of files, then we have a lot of lines of code. And then since this have a lot of lines of code, then the problem is this huge number of line code, it increased the complexity. So, and because of this complexity, it is very difficult to understand and find the bugs and make the fix correctly and fast. So, and then it takes more time in order to test, build, and release, because every changes, you need to run the test. And then to run this test, there is a lot of tests. There is unit test, for example, and there is manual test, there is automatic testing and other testing, chaos testing, and so on and so forth. For example, here I have the movie, I have enabled the unit test, and the unit test should cover 85%. If it is less than 85%, then we need to improve the unit test coverage. Otherwise, the pipelines, whether we are using Jenkins or other pipelines, they will not allow you to deploy or to release the package to the SIT server or even to the UAT also, right? So this is the problem that we have because of the one repository, and we have a lot of files, we have a lot of lines of code, and it is very large, it's very complex, and also it's very takes more time to test, build, and release. Every one single changes, because of one repository, you need to test all the files, the test file, all the test script, all the test scenario. So this takes more time. And since we are using one repository, definitely we only have one technology stack. So the technology adoption is become low. For example, if you are using React.js in here, then definitely you only use React.js to create other component. If you are using Angular, then most probably we only use Angular for all other component, the new component or updating the component. And then since we have the release trend model, we will have a loss update that I explained. If we forget to bring the commit or the fix in the March release branch to the April branch, then we will have a problem when you deploy the April release branch to production. So we call is this loss update or missing fix update. So this is happen also in industry currently. So this is like a common problem. So with this common problem, what we try to achieve is that we want to have kind of a framework or a solution or approach that it allows user to create a multiple repository. That's the first objective. So what's the multiple repository? So for example, I give back to the Undip. So for example, in home, we will have one specific repository to manage the home source code. And the profile, we have one specific repository to handle the code about the profile, and so on and so forth. So it means if you see here, we will have 1, 2, 3, 4, 5, 6, 7, and 8, maybe 10 with the search. So we will have 10 repository to handle this one page. And each repository will be handled by a specific team, whether it is agile or waterfall. So we have a specific team dedicated to manage that repository. And of course, we will have their own pipeline. They have their own Jenkins pipeline, and they have their own release schedule. And with this micro front end, we can use the trunk-based model development. So it means we only have one trunk as a single source of truth. So any code commit or merge, you need to put into the trunk. So with this approach, we will handle the loss update. So because all the developer only commit into the trunk, and from the trunk it will release for them, whether it is for March release or April release and everything. So the trunk is become a single source of truth of your source code. Okay, so if there is some problem, for example, in the release 12.1, what you need to do is you need to do a cherry pick from the trunk, the commit ID, and then put into the release 12.1. So we need to have a cherry pick from the trunk to the release. So we cannot directly commit to the release 12. Otherwise, the trunk will have a problem. Okay, so you can go through all these things. And yeah, so the one of approach that enable the micro front end is a single SPA. So basically, I just directly from the main page. So this is the single SPA. So the single SPA, it allows you to freedom framework. It means whether you want to use Angular, React.js, Vue, because it may that you create the home page using Vue. You can create a profile repository using React.js and others. Okay, so it allows you to use whatever framework that you are familiar with. Okay, and then of course to make it more faster and everything, you can do lazy loading and everything. And then yeah, it combines. You can combine many small applications into one page like this undip.ac.id. Okay, so if you go to the documentation is very helpful, and there is a demo and example. So I will also display the demo today. So this is the overview about the micro front end, and yeah, the details you can just read into this document, into their page. So in this, I want to before you saw a demo, the second approach is about the model federation with the Webpack 5. So maybe later on, it will very I can explain in very easy when we saw the demo. So this is called module federation. So it allows you to build from multiple repository into a single application. So we also have the live preview. So later we will go as a demo. So now we can see the demo for the single spa. So I have created, later I will share this PPT. I have created a lot of in my GitHub. So you can also follow the step, the how to start with the single spa. So you can follow this one. So, but I have create a simple example or the demo for the single spa. So you can go to all these things. So you need to download all this 1, 2, 3, 4, 5 repository, and then you can run in your local. So I have done that. So this is the single spa. I have 5. So I have this config, and I have this home, and then I have this login, and this is nav. So this one, for example, it is running in a specific. Let me clear npm start. So I can. This one is running on port 9000. So the config will run in the port 9000, and home is in 9003, and login is 9004, and this one is 9002, and the API is 9001. So when you open the page, is basically you need to run, you need to open from the config. So you need to run from the 9000. So this is the one that the result of the microphone end. So all this source code is coming from a different source, different repository, which is running in different port or different server in the production, whatever. So you can create, whether it is using containers in Docker, or you can put into the S3 bucket or any bucket in Google's or Azure. So basically you can just, because this is a static content, you don't need to have a backend service to handle the logic and process. So basically we just need to have a live support services to load the static content. So if you want to see where this the file is coming, so if you go to the network, if you refresh again, so we have this what we call info map. This is the very important file that to where's this? Oh, this one directly in the file. So in the file, if you see, this is very important part, that to mapping the so I will just go to directly to the code. So this is the config. In the config, there is all microphone layout, and this is EGS. So this is the one that we mapping that anything related to the home, it will be served from the 9003. Okay, so when you click this when I click this home, it will all load the JavaScript which is coming from the 9003. So this is coming from 9001 because I need to have the API to call this home page. And this is the page is coming from the 9003, and this is the nav navigator is coming from the 9002. So all these things are handled by this mapping. So this is to allow the microphone work with the single spa approach. So you can create as many as you want, and as you need it, of course. And then, yeah, you can create a different repository for each feature or each menu or each page, and allows you to handle by the different team, and they have their own Jenkins pipelines, and they have their own release schedule. So it means if there is some changes in the home, you only need to build, only need to test and build only for this particular repository. So you don't need to worry about the login, because your changes or your fix is about the home. Okay, so if there is some changes in the login, so you need to just to fix in your login repository without affecting the home repository or other repository. So if I click home, this is the repository. If I click login, and this is the login. I haven't created, just a simple that this is a login. Okay, and if you see that there is two buttons, this is the button, and this also the same button. So this button is basically is shared between repository. So if you go to the home, in the component, in the home, this one, I have this button, and we display this button. Okay, so this button is basically we create from, sorry if I a little bit slow because it is very important. So we share from this one, from the nav source repository, code source repository, and then we share to the home and to the login repository. So this button is coming from the navigator repository. So, and then we can access from the home here, and we can access also in the login. So I will show you in the login. If you go to the login, you go to the login. This is the root component. See, this is button. It is coming from the nav. So when there is this add subtract Khairul / navigator, so it will go to the this import map, and then they will take what is the Khairul navigator. The Khairul navigator is coming from this static file JavaScript. Okay, so and then after that it is loaded on the fly in the browser, and then they will run directly. So if you check in the packet.json, this just now in the login, this Khairul nav does not exist in this packet.json. So it means we do not need to install as a dependency or dev dependency. It is directly accessed on the fly by the browser. So since we have this mapping that the Khairul nav will take from this source, right? When this login page is rendered, then it will take directly, I refresh again. Since it is login rendered, then it will take the button from the Khairul nav.js, which is defined into this. Okay, so this is about the single SPA. So with this single SPA, it allows you to create a micro front end, and each menu, they have their own repository. And since it has their own repository, they may have their own Jenkins pipelines, and they have their own test plan, release schedule, and etc. Okay, so next we go to the module federation. So it is very straightforward. If you open the documentation in the module federation, we just need to click this live preview. So when you click this live preview, you will see all this code. And if you see the difference between the single SPA and the module federation, they need to play with this webpack. So in this webpack is basically you need to create this called module federation. Okay, there are two types of module federation. One is the one who expose, who share the component. Okay, this is the first one. It means you need to expose your component, which file you are trying to expose, and then what's the file name that I can use to access your component. And the second one is the one who want to import or you want to use. So it means you need to define as a remote. So if this is a remote, you need to define what's the URL, and then what's the file name, the JavaScript file name. So whatever that you define here, if it is you define X, then here you need to as a X. And then since it is you want to consume, then you need to define as a remote. And then, of course, you can share whatever that you have, whether it is using React.js 17 or 18, or you use React Router DOM or any React Redux and everything. You can share this one to the app 1 and to the app 2. Okay, so it means the app 2 just consume whatever the React.js that has been run in the app 1. So with this one, if you can see that in the app 2, it's basically, if you see here, they want to share this file, the app, under SRC folder. So they want to share this kind of. So if I check this one, so it will run, and then they will run again, compile, and then deploy. So using the module federation, basically you need to mention manually which component you want to share. And then you need to also which component do you want to consume. Then after that, you can share your component to other repository or to other pages, and so on and so forth. Okay, so this is the difference between the single SPA and the module federation. Okay, so the module federation with Webpack pipe, you need to specifically to define whether you want to consume or you want to share in every repository. So for example, you have AP1 repository and AP2 repository. You need to specifically create into the Webpack file. In other way, in the single SPA, you don't need to worry about all these Webpack files. So you just need to maintain one file called the import map. So you can also host as a static file, and then you can also host a backend API as long as you receive this content. Okay, so if you compare that in the single SPA, you don't need to define anything, whether you want to share or you want to consume. So you don't need to worry about that. You only need to maintain in one file, which is under the config repository. Okay, and then how you can share is basically, it is very straightforward. So if you want to share in any repository, you can go to, for example, here you just need to export. So for example, in the navigator, I have export the button. So here you see here, I have export the button like this. Simple, like you write export in any React.js file or component. You just export, that's all. The login can use, the home also can use. So in the login, you can just directly export like this. No need to worry about the npm install and everything, and no need to worry about the Webpack, whether you are consumer or you are producer. Okay, and then this is home, also similar. So in the home, you have the home, we have the button. So you just need to import easily. So I think that is the last slide. So we can open for a discussion going forward. Thank you. Hello.
All right, students and all participants, you may raise question now. Okay, Gani Arya Suta.
Okay, I should see in the chat, right?
Yeah, there's no question. Yeah.
All right. Thank you for the time. So I'm going to ask a small question. I have not actually heard about something like this, basically from an application that can be sliced up into multiple frameworks, but would there be any performance implications for using multiple frameworks in one app? Because as far as I understand from the presentation, so basically we have to load the whole framework at a time of loading
not at
a
that
new
time.
page.
So it is not at that time. You can enable the lazy loading. Lazy loading is mean when you try to load the component, when you try to render the component, then the browser will try to find the JavaScript.
All right, but we still have to load those frameworks.
The framework is only load in the first step. So, and then the rest is when you try to render the component, if this component does not have exist in the memory of the browser engine, and then they will type to the mapping, what's the JavaScript for this particular code. And then they will search, okay, this is the JavaScript. If that does not exist, they will load. And yeah, and then about the performance, is that your question, right?
Excuse me?
About the performance, that's
performance.
mostly your concern, right?
Yes.
So about the performance for the static file is basically you can play with the CDN, content delivery network, which is based on your IP address. It will try to find which server it will be near from you. Okay, so this is like a common for big industry. So when you try to serve the static file, you need to using CDN. So there's a lot of CDN. There is Akamai, there is Cloudflare, and also CloudFront from AWS. So we have a lot of CDN. So it's mean the performance is basically based on the network mostly. So if you have a good network bandwidth, then it will be faster. So if you have a very small bandwidth, then it will be impact your performance, of course. And the rest is about how you write the code. So how you write the code, for example, here, you can create directly import like this, right? If you realize that in the React.js, they call React lazy load, right? Have you heard about this one?
Yes, I have.
Yeah, so the lazy load will help you that they will only loading the JavaScript when you render the component if the JavaScript does not exist in the memory yet, or the component does not exist in the memory yet. So you can use the lazy load to boost the application. So for example, the simple things is like this. When I call the API, it's very fast, even though I click so many content data here. So about the performance, one is about the CDN. Second one is about your user bandwidth, of course. The third one is about how you write the code. To make it faster, you can consider to use the React lazy loading.
So as far as I understand, the Webpack size would be still larger than the usual. Oh, no.
No, if you are using lazy loading, it will become smaller. If you see in my here, I have tried to reduce from the 3 megabyte into small kilobyte and bytes only. How I can achieve this? Because I'm using a lazy loading. So when you create a React lazy loading, it will create multiple files in small chunks size.
What about multi-page state, like global state for one application?
Yes,
can it handle it?
Yeah, yes, you can. So it's depend to your design also. So whether you want to share your data store, so whether you want to use Redux or you want to use only React hooks with the context and reducer or others approach. So you can share all this data basically. So we already implemented this one in my current companies basically. So we are using this. So we are able to handle all these things, sharing the data, sharing the component, and there is no problem with the performance because we are using CDN, and we are implement a lot of lazy loading, and it's become size files, it's become very small, and yeah.
All right, thank you, but
No
I have a little question again. So as far as I understand, like frameworks like Next.js, it can achieve, let's say, super fast performance is because the Next itself, the framework itself, caches the data, the the result of the rendering on the server side, and then we can just send the HTML to the user. So because in this case, each app could have multiple frameworks, how would it handle those kinds of caching?
So yeah, again, if you are using a multiple framework, one is using Angular, one is using React.js, at the end of the process is only a JSON object, right? So either you want to share using directly the JSON object, you using the import statement, so you can just import your component or Redux and everything, whether you're using use context and everything. So I have a lot of example in the React.js, whether you want to use context and multi-reducer like that. And yeah, you can, this is the React DOM, and this is the using the hook. So for example, test. So this one is different file and different pages, and then I can share among the pages about the data. So, and then, yeah, so you can actually, we have a lot of approach in the React.js. So the problem with the server rendering is if there is 1,000 or 1 million user, then the server we need to have a big server. But if you rendering directly in the browser, you don't need to have a big server. You just need to have a static content services, right? So you don't need to handle the memory. All the memory can be handled in the browser of the client. So, and then another is you can also consider this. I can remove in the browser. We have a lot of, there's a local storage and there is also session storage, right? So you can cache your session data into the session storage. It means when you kill the browser or you close the tabs, it will destroy it, right? And then you can put it wherever that to make your performance faster. Otherwise, you can also create an object like memory cache in your JavaScript, and then using the global store, and then you can share. So whether you are using Redux, Saga, or Redux Tang, or React hooks, context, and reducer, then you can handle all this data in the browser itself. No need to have a server to manage that caching.
All right. This is a very cool project for me. Thank you for sharing.
Sure, no worry.
Right. Thank you, Gani. Pak Khairul, may I ask your permission if any students who ask in Indonesia?
Yeah, can.
Yeah.
So I can also in Indonesia.
Okay, thank you. So students, if you like to raise question in Indonesia, it would be okay.
Yes.
Go
ahead.
Silakan. Oh, Gani again.
Oh no, I'm sorry, I forgot to lower my hand.
Yeah, audience, you may ask your question directly, or you may drop your question in the chat box. Okay, while we are waiting, Pak Khairul, yeah, I'm impressed. You're a vice president, but you're still coping with coding, etc. So,
yeah,
is it your daily job?
Mostly on the design. So I need to do a design, and then of course about the code review. So basically we have very what we call a good approach, a good process, standard process, SOP. So every time you make some changes, you need to create your own branch, right? Feature branch. And then after that, you do whatever changes required by the story ticket. And then once done, you need to use that story ticket to commit and push the code into your branch. Then after that, you need to create a PR. So when you create a PR, pull request, then I need to jump in and then review the code, whether you are following the best practice, whether you are following the principle, whatever the principle, the Hollywood call principle, the single responsibility, the fail fast, return early. So we need to make sure that the code that you put it in, that it is safe and it is not brick, and then you need to have a code coverage more than 85%. So, and then after that, I can approve your pull request. Because at the end, if there's some problem in the production, of course, the one that who accountability is, all the senior level, right? So, but we want to make sure that from the beginning that all the code that you put into the branch, it is safe.
All right. So you're still practicing your programming skills, maybe from basic to advanced one.
Yeah. And if there is new things, for example, like this, Khairul, we want to move to microphone, and can you do some POC? Oh yeah. Then at that time I need to, no choice. I need to write a code, right? And because I need to read and I need to try, error, try, error, and then after that we can get some level understanding. Then after that we can share to the others.
Yeah. So maybe you have to train a new programmer as well.
Yeah. Every day is like, I always tell to the team, don't stuck more than 10 minutes. So if you spend more than 10 minutes in something, please approach me. And with this approach, that we can deliver the release, and everything is on time, on schedule, and there is no big issue or SLA one issue in production. Yeah.
All right. Well, we are still waiting for questions from students, I guess.
Okay. It's okay.
Yeah.
So you can ask me at any time, whether you if you have my email, you can send your question to my email. If you have my LinkedIn, you can also go to my LinkedIn. So this is my LinkedIn, Khairul Answar, and then you can send a message at any time, and yeah, we can share and sharing anything. Maybe also I can learn from new thing from you guys.
That's very kind of you.
Yeah.
Well, I have one question about the cross repository things. Is it any problem with inconsistency or something like that?
This one, right? So when you use the release trend, we will have a different release branch, what we call, for example, because each release branch, they have, say like this, right? You can see my screen, right?
Yes.
So like a trend has their own regular schedule to depart, right? One is for March, one is for April. The problem with this one, right? When there is some problem in production in the March release, they only fix on the March, because the current release for the production is March. And when they forget to do this the arrow, the green arrow, right? Then when you release the April, it will really override whatever in the production, correct?
Yeah.
And then with that approach, we will lose whatever that we do this green commit. So this has happened. I have experience also in one of the company that, hey, we already fixed this issue on February. Why this issue is coming again? Then after that, when we check, we compare the code, then, oh yeah, I forgot to bring this commit to this April. Then that's gone. Then yeah, the problem is coming, why and why? Because there is some human intervention here. So there is manual process in order to sync between the March branch with the April branch. So that's why we in any development now, they want to move from this release trend to the trunk-based model. So we only have one source, single source of truth, which is what we call trunk. So any fix, whether for production or UAT or SIT or new feature, you need to commit to the trunk first. Then the next release, there will be no issue, because the release 12.2, they will branching out from the trunk, and then whatever that you already commit to the trunk, it will be built and deploy.
Okay, so it could be said that the company only maintain one version of release in any time, right?
Yes.
Right. Okay.
Oke,
Well,
semuanya pada malu.
ya mungkin ada problem dengan bahasa, Pak.
Oke.
Ya,
Makanya tadi saya tanya apakah saya harus pakai bahasa Inggris atau bahasa Indonesia karena takutnya ini hal yang menarik yang harus
ya,
dijelaskan dan mungkin bukan hanya untuk pada dosen tetapi mungkin para mahasiswa yang kemudian hari dia akan lulus dan mencari pekerjaan dan ini akan menjadi apa ya satu skill set yang dibutuhkan di masa depan. Sekarang mungkin orang masih berbicara React.js, Angular, Vue, all these things. Kebutuhan industri itu udah berbeda. Anda cuma tahu React.js itu mungkin ya udah 1.000 orang, 100.000 orang sudah tahu React.js. Tapi apa yang menjadi nilai tambah ketika Anda mengetahui micro front end gitu. Secara sederhana Anda juga bisa googling about single spa. Silakan googling, kemudian modul federation webpack type. So kalau Anda memiliki dua skill set ini itu akan menjadi nilai tambah. Karena sekarang yang ingin dicapai sama semua company adalah meminimalize kesalahan dan mempercepat proses. Time to market menjadi hal yang important, yang sangat penting. Jadi kenapa kita pengen mengatasi masalah-masalah yang ada di sini? Karena masalah yang satu tim, satu release schedule, satu repository itu sangat lambat prosesnya. Development prosesnya sangat lambat. Nah itu sekarang di Singapura itu orang sudah berorientasi kita harus pindah ke micro front end. Mungkin di back end itu sudah sangat apa ya, sangat jelas. Microservices itu udah dari tahun 2010 atau 2009 ya. Orang sudah berbicara microservices. But micro front end ini baru-baru saja. Bisa dilihat dari kapan single spa and modul federation ini ditemukan. Gitu. Bisa lihat dari apa? Dari dokumen yang mereka buat itu baru-baru saja. Gitu. Oke, jadi kalau misalnya malu-malu, cukup coba buka-buka tentang single spa. Nanti juga saya akan share PPT-nya. Kemudian ini modul federation dan ya saya juga punya beberapa repository di sini yang bisa dites, di clone. Nanti saya share PPT-nya, di PPT juga ditulis apa saja repository yang dibutuhkan dan URL yang dibutuhkan untuk belajar tentang single spa sama modul federation. Oke, so almost 1 hour ya.
iya. It's almost.
Yeah.
Well, I have one more question.
Sure. Go ahead.
Is it does it have any connection with interoperability from
Yeah.
platform to another?
Actually, at the end of the process, right, similar like this one question when we do use different front-end framework, whether it is React.js or Angular, and etc. Ketika kita menulis React component, is basically the Babel will translate into the React.js, correct? So begitu juga dengan Angular or Vue. When you write in the Vue or Angular, they will translate into become React.js because the browser is only understand about JavaScript. Okay, so the browser doesn't understand about React.js. They do not understand about Vue or Angular. When you do build, npm run build or wherever that build, is basically they will compile into JavaScript. So when you load everything, for example, this all the source code will be served as a JavaScript because the browser is only understand about this JavaScript.
Yeah.
Okay, so there is no problem with the interoperability, but it is very helpful for the user. For example, this team is only familiar with Angular, just go ahead with Angular. And then this team is familiar with Vue, just go ahead. And this single spa is helping you to combine and serve it into one page. in this page, it is very clear. Yeah, this is the common problem that they want to solve. So I think they already have this question when they're trying to work on the microphone end, and they already solve it.
That's good. Okay, Pak Khairul, we have another question in chat box. I'll
Sure.
read for you. Yeah, from Pak Ade Setia. The
Ya,
question is,
sama pertanyaannya. A question: when we use different front-end framework, do we need to standardize all the micro app? For example, how to store the data? Yes. So basically, at the end, the process that the data is a JSON object, right? So when you try to transform from one data from one app to another app, or from one microphone end to another microphone end, what we call MFE. So you need to pass as a JSON object, right, with the standard format. And why now a lot of industry is using TypeScript, because we want to standardize all the structure, right? So we cannot rely only on the JavaScript like this. This JavaScript is there is no logic whether this data format is correct or not. But using TypeScript, they will tell you that, hey, your pass is the wrong thing. So if you want to fix it, you need to use the same type. So yeah, so that's why everything is we need to define as a type, and then we need to load it with using the React. Using the TypeScript, it is helpful to standardize the data.
right. I hope Pak Ade will get the point. Pak Ade, do you still have any question, or is it good? Okay, Pak Khairul, I have another question, but it's not only technical.
Sure.
Is it okay?
Yeah. Go ahead.
Apart from technical skills that a student must have before they graduate, what do you think about the soft skill? What are the skills they need to possess before they graduate?
Yeah, so basically, the most important that you need to understand about all this concept. So this Martin Fowler is very famous guy. So you need to spend your time to read all this, how to what's the pattern to managing your source code. So there is some different approach. And of course, also you need to read about this trunk-based model, because your knowledge is help you understand how to solve the problem. Why micro front end is we need it, because we need to have understand about all this concept. And the rest is how I will give a question. So you are in the middle of nowhere, so you can only turn left and turn right. You only have these two choices. So now you need to find one object, whether it is in your right or in your left. So what we can do is at that time, so we go 1 meter to the right. If I cannot find, then I go back to the middle, and then I go to the left 1 meter. If I cannot find, I go to the middle. And then after that, I need to increase, because if I just keep 1 meter, then I cannot find the object. So after I go 1 meter to the left and to the right, and the next I need to go to 2 meter to the right. If I cannot find, go to the middle, and then 2 meter to the right. So this one is how you solve the problem. First, you don't think about the very optimized solution. You need to use like brute force solution, which is not optimized one. Okay, so this is the one that this is not optimized one. You go to the right 1 meter, go to the left 1 meter. I cannot find, then 2 meter to the right, 2 meter to the left, and until you find the object, whether it is your left or your right. This is a common. When you try to solve the problem, please don't think about the optimized solution. Okay. Now, after you find the specific solution, and then you think, okay, so how can I optimize it? So now, if you just adding 1 meter, then you will be choose your time, just go back to the left and to the middle all the time. So instead of only 1 meter, I can go using the Fibonacci. 1 meter to the right, I cannot find, maybe I can go 2 meter into the left. If I cannot find, then I can go 3 meter to the right. Then it's become faster and faster. Or you can also put like multiple n plus or n times 1 or n plus n times 2. I cannot find 2 meter to the right, I go to left 4 meter. I cannot find 4 meter into the left, then I go 8 meter to the right. So at that approach, you can optimize your solution. So this is like a skill that you need to have when you see the problem. Don't think about the optimized solution first. You just start with the simple, and of course, maybe it's not optimized one. It is okay. Then after that, you try to improve. I think in all the research is similar. You try to about a distributed database, how to handle the consistency, and then you try with the not optimized side. Then after that, another research will come out. Hey, my approach is better than you because I optimize it. And then next research is similar like that. Yeah, that kind of kebiasaan yang harus dibangun ketika kita melihat masalah dan kita ingin menyelesaikan masalah. Itu mungkin yang bisa saya share. Ada lagi?
Yeah, so basically we have to practice continuous improvement ya Pak ya.
Iya, jangan berhenti. 1 konsep, belajar konsep, 2 yaitu mulai yang dari yang mudah, kemudian kita cari yang optimize.
Well, we have another question from students, Agung Surya Permana in chat
Yeah.
box. The life cycle index is simple but ambiguous. The dependencies of the React hook are weird. What I mean when compared to other frameworks like Vue, Svelte, why is React still widely used?
Ya mungkin ada kesalahan dalam mencoba untuk memahami ya. Awalnya banyak perusahaan itu menggunakan Redux Tang, Redux Saga, itu sangat sulit untuk dipahami, untuk dimengerti. Dan kenapa semenjak React versi yang ke-16 itu mereka mengintroduce yang namanya React Hooks. Itu karena lebih simple. Jadi ketika bedanya itu di React itu semuanya itu dalam asynchronous flavor. So kamu mengupdate sesuatu data, karena data itu dia bilang nggak bisa diupdate directly. Dia bilang immutable. Ketika kita membuat objek itu immutable. Immutable artinya kita tidak bisa, misalnya ketika Anda sudah mendeklarasikan var A sama dengan 2 sebagai store, Anda tidak bisa merubah A itu menjadi 3 atau jadi 4. Gitu. Nah, yang bisa hanya merubah itu misalnya kalau menggunakan React State itu ada variabel dan set variabel. Jadi misalnya variabel namanya A, kita buat set A sebagai function untuk merubah si value A itu. Gitu. Jadi sebenarnya mungkin hanya kebiasaan ya. Kebiasaan orang yang sudah menggunakan Vue ya terus menganggap Vue itu adalah hal yang lebih mudah. Nah, sekarang React.js itu udah mulai mempermudah, nggak usah lagi menggunakan Redux Tang atau Redux Saga. Makanya cukup dengan React Hooks, dan React Hooks itu sangat sederhana. Cukup menggunakan satu objek, satu set objek, itu aja. Dan kemudian kalau kamu mau merubah menggunakan set objek, kamu nggak bisa merubah directly objek sama dengan 2, kemudian nanti di satu saat objek sama dengan 3 atau 4 atau 5. Karena si objek yang sudah dibuat itu harus jadi immutable. karena untuk mempermudah untuk memanajemen di memori. Ya seperti itu.
Alright, we have a hand
Another.
raised from Kenny Arya Suta.
Yeah,
Okay,
thank you
Kenny.
for the opportunity. I want to ask again about the system that you were talking about. So we can basically use multiple frameworks in one page, right? As far as I understand.
Correct.
Yeah. So what about if we combine something like Next or React, which is hydrated on load, and then we combine it with something like Astro, which is partially hydrated. So would there be any problems with that, or it is already
Jadi
handled?
sederhananya React itu kan sebenarnya at the end of the proses, React itu cuman mencari HTML elemen yang bisa saya pakai sebagai kontainer untuk ngerender komponen saya. Jadi Anda bisa bayangkan Anda punya HTML, ya HTML. Kemudian di body Anda punya beberapa, ya kan? Anda punya ini untuk div, untuk ID sama dengan untuk React, like this, and then ini untuk view, ini untuk Angular, seperti ini. Jadi nanti ketika kita mau ngerender, kita cukup untuk React kamu ngerender di bagian sini, untuk view kamu ngerender di bagian sini. Itu konsepnya. Ataupun mau yang pakai server rendering, nanti server rendering kamu cuma ngerender di bagian sini aja. Gitu. Gitu. Makanya single page application itu sangat memungkinkan untuk menggunakan different framework.
Okay, so about partial hydration, which is they have a very different system from Next and React and Angular and other things, because it is actually managed by the Astro, what should we call it? Is it a framework? Yeah, Astro framework. But in this case, Astro simply sends the data to the DOM, right?
Yeah. So basically, kalau ini kan cara bagaimana React ngerender. Ketika kita melihat this Babel, ketika kita membuat komponen, sebenarnya React itu meng-execute gini. Gitu. Nanti si ini itu akan ngetes, saya akan nge-execute ini sama si yang React create root DOM ini, dia akan ngerender di sini. Nah, another approach that we create a component is using the inner HTML, right? So you can create like document got element by ID, but of course this one we need to have because you are sending from the HTML content. For example, the HTML content is type similar like this. So when the server sending this, then you can deliver and then render into, for example, I want to render from here, on here, like this. So when the server is basically sending to the browser is already in the HTML flavor, right? So you can use the inner HTML in order to render. So it will render indeed here.
All right, I kind of get the system now. All right, thank you very much for the answer.
So for the rendering the the component into the browser. For the simple HTML, I think is not required a GPU, right? For example, but if you are using Canvas, yes, it will require a lot of GPU in order to render the content. But if it is like HTML page element, I think there is no GPU required to render all these components. But if you are using a browser canvas element to render the content and then the graphical content, yes, it is required GPU. And yeah, only that part. And it is not about the framework. It is about the browser canvas, because it trying to draw all the lines, the dot into the lines into polygon, and so on and so forth.
Right. Is it good, Gani?
Yeah, thank you for the answer. I have understood the system.
Yeah.
Thank you.
Okay,
Yeah.
thank you. We have another question in chat box from Pak Adi Wibowo. We developed AI model in Python for several video processing in one web page, and then we converted to GS to make it run on web-based. But we could not yet run it in parallel using GPU in our client. Most of process using CPU. Therefore, we need high CPU processor. Use a TensorFlow.js as framework.
Yeah, so currently Python of course bukan tidak bisa jalan di browser kan, jadi harus di backend. Nah, sekarang pertanyaannya adalah several video processing in one page, and then we convert it to JavaScript and make it run on the web base. Oke, ketika kita menjalankan video di browser, is basically they are using browser video tag. So this is specific tag element for the browser to play the video. Okay, so in the background, of course, the browser engine will handle all the frame per second process. Okay, so when you try to analyze that video, of course you can analyze by frame, right? And then there's a lot of AI library also, for example, for text recognition in the image. It is possible now in the JavaScript. So because basically the browser now is become more smart, so you can just read from the screen and then you can get the data. We have experienced that to read the passport, and then you want to extract the text from the passport, and the user no need to enter manually what's the passport number, what's the expired date, what's the name, and so on and so forth. So we are able to read basically. They have some process whether you want to make it the password is become high contrast, so you can only you can make a decision whether you want to make it white or black, right? So after make it white and black, because maybe your photo is first time is a color photo, and then you upload, and then the library will handle that process, whether you want to put your pixel is become white or black, and then after you make it as a white and black, then you can make a decision on this particular character, whether it is A or B or C or D. So now it is possible. And yeah, that one is only to have to read the text from the image. Similar with video also. So from video is basically is like image per second. So you need to take image, and then you need to extract whatever that feature that you want to extract from that picture. And TensorFlow, I think it's not like directly run in the browser. It is the backend, but yes, there is a JavaScript library that they can use that logic, the same algorithm that can implement into the browser. And the GPU, the problem with the AI is you need to have a test data. So when you create a test data, it will consume a lot of memory, of course, because you want to store it on the cache and the browser. And then you can use that test data to analyze and make a decision. So, and then you can verify your test data, your algorithm, whether it is good or not. Then you can test your data. So basically, the memory consumption is only to store that data, because that logic for the test data. And yeah, using that test data, they build the model, and they can use that model whether it is valid or not. And for most like not similar like banking or any kind of pages, they do not have kind of AI to enable. Even for the Netflix also, the AI and ML is mostly on the backend, not in the client base or not in the browser. So for example, in any company, they will have like Google Analytics, Adobe Analytics. So when you move your cursor, your mouse, it will send the data to the backend, then we can analyze. And based on that one, you can give some recommendation whether you need to buy this product or that product based on your mouse movement. It's not based on your. And then for the movie, for example, Netflix, when you play, it store the data in the backend. Okay, you already play this kind of movie, then I can make a suggestion. And then all this logic is under the backend. But for the front end that you want to use, you can also send the image to the server. And then server, they can do a process to get some insight, right? So instead of because we don't know, we cannot assume that the user will have a good computer or machine, right? So that's why when for example, I want to read the passport, we can make some assumption that the machine is not good. Yeah.
Sorry, I think you lost your voice.
Oh, okay. Yeah. So basically, either for the machine learning, whether you can send your data into the backend and let the backend handle that process. Because when you try to handle the process into the browser, we cannot make assumption that the browser, the computer machine of the user is good enough to handle that kind of machine learning process. So if you want to, since it is your personal project or anything, so you can just send the data to the backend and let backend handle the process.
Okay, all right. I hope it's okay, Pak Adi.
Pak Adi?
Thank you, Pak Khairul.
Sama-sama.
Yeah, wait.
Ada echo.
Sorry. There is, because we are in some room.
Some room.
Ya. Jadi mungkin saya bahasa Indonesia aja kali ya, saya bingung.
Boleh. Silakan.
Jadi semacam ada nggak ya sih microservice yang bisa menghandle. Jadi kita memang kemarin mau menggunakan backend di Python base gitu ya, Flash dan seterusnya untuk ngefeed image processing yang kita lakukan ya, video sebenarnya, karena kan real time pakai kamera dan problemnya kita harus 100 fps ya, jadi agak cepat, kebutuhannya cepat. Nah ternyata pas kita coba pakai TensorFlow.js library-nya, kemudian modelnya kita convert ke situ, pas satu ROI, satu objek, satu frame video, komputer biasa masih mampu gitu. Tapi ternyata karena kita butuhnya 6 ROI, ya kita masih menggunakan prosesor bagus sih di saat ini. Jadi agak ini. Nah, tapi pas utilities GPU-nya itu nggak jalan. Apakah memang kalau di browser base untuk akses GPU
masih
belum ada frame atau belum ada yang seperti Python gitu yang belum ada ya memang?
Belum.
Okay.
Jadi kalau karena browser itu kan sebenarnya lebih masuk ke presentation layer, bukan ke processing layer.
Oke.
Karena di desainnya memang untuk presentation layer belum bisa kayak menjalankan di desktop aplikasi gitu, kayak di server atau di backend. Gitu.
Oh, baik.
Jadi memang biasanya browser itu hanya untuk presentasi aja, untuk menampilkan apapun yang kita ingin lihat, gitu. Tapi kalau misalnya prosesnya Anda pengen menganalisis dari data gambar, kayak tadi misalnya saya mengupload data pasport gitu ya. Ada dua pilihan, saya bisa menggunakan JavaScript library untuk mengekstrak semua teks gitu ya, atau saya kirim si gambar ini ke backend. Nah, the backendnya nanti yang ngeproses, karena di backend itu bisa scalable, Anda bisa nambahin dua mesin, 3 mesin, tergantung dari ada core-nya atau apa segala macam, GPU-nya juga gitu. Tapi kalau untuk front end kita nggak bisa scalable kan?
Berarti bisa dikatakan kan kebetulan kami mencoba untuk attach GPU di komputer tersebut. Berarti kalau berarti masih kecil kemungkinan GPU itu bisa diutilize menggunakan web base.
Mungkin
maksudnya tanpa backside, tanpa backend Flash atau Django dan seterusnya gitu ya berarti.
Ya, masih belum bisa. Karena kan yang paling penting itu kan sebenarnya scalable-nya, bukan GPU-nya.
Scalable-nya, betul.
Ya. Jadi kalau misalnya kekurangan saya bisa otomatis menambah, tapi kalau di browser itu nggak bisa seperti itu. Di klien itu nggak bisa.
Di klien nggak bisa ya.
Kalau di backend kan bisa. Kalau misalnya kita pakai apakah ke container based aplikasi atau apapun gitu, ketika ada worker atau segala macam kan bisa nge-spin mesin baru untuk ngejalanin si worker ini. Tapi kalau di browser masih apapun yang dipakai saat itu ya itulah, berapa memorinya, berapa core prosesornya segala macam, nggak bisa scalable. Jadi untuk proses yang sangat high intense itu butuhnya itu scalability sih sebenarnya, bukan besar mesinnya. Sekecil-kecil nggak apa-apa, asal banyak gitu aja, bisa nambah sendiri juga.
Baik, terima kasih Pak.
Sama-sama.
Alright, thank you Pak Adi. Well, we have no questions anymore. It's almost 12 o'clock.
Bebas.
Yuk silakan kalau mahasiswa ingin tanya dalam bahasa Indonesia.
Boleh. Sekarang ada berapa mahasiswa yang masih ada yang dikirim ke UTM nggak? Balik nanya.
Pak Adi mungkin bisa menjawab ya Pak.
Atau udah nggak ada lagi yang di UTM?
Pak Adi?
Pak Adinya lagi.
Izin menambahkan, Mas, jadi kalau Pak Khairul, jadi kalau UTM itu kan di Oktober nanti rencana dia mau main ke Indonesia. Nah, salah satunya itu ke Undip untuk MOU, tapi kita belum tahu bentuk MOU-nya apa gitu. Jadi kita para alumni itu sedang dikumpulkan sama UTM nanti untuk bikin MOU lagi.
Bagus. Udah lama yang nggak ke Melaka. Terakhir itu pas wisudaan aja. Masih sempat sih ada wisudaan tahun lalu 2021 Maret. Okay, so what next? Udah hampir sejam setengah ya?
Yeah, 1 hour and a half. Alright, well,
satu lagi dong Pak Khairul, boleh nanya?
Silakan.
Boleh, silakan.
Tadi Pak ya, yang buat misalkan video rendering itu mayoritas ditanganin sama si HTML ya, bukan si JS-nya sendiri ya. Jadi framework JS apapun misalkan Vue.js, Node.js dan seterusnya itu tidak mempengaruhi ya sebetulnya ya. Tidak ya.
Iya, enggak. Jadi sama si browsernya itu yang nanganin. Kan di browser itu ada namanya video tag ya. Video tag kemudian kita harus mengasih source-nya apa. Jadi ketika menggunakan tag itu nanti si browser engine-nya itu mungkin ya yang akan nge-handle. Jadi mungkin dalam level C++-nya si browser engine itu.
Baik.
Gitu.
Ada perbedaan mencolok nggak sih antara browser satu dengan browser lain, Pak Khairul? Dari sisi
Hampir
front
semua
end?
sekarang menggunakan Chrome. Sekarang kalau misalnya lihat Internet Explorer kan udah nggak ada ya. Si Edge itu juga udah menggunakan Chrome Engine.
Oh.
Jadi sekarang semua itu udah menggunakan Chrome Engine. Safari juga menggunakan Chrome Engine. Jadi sebenarnya Chrome yang jadi pemenang dalam masalah. Tapi Firefox masih menggunakan engine yang lain. Saya lupa namanya apa. Firefox masih menggunakan yang lain. Tapi Safari, Edge, Chrome itu udah menggunakan Chrome Engine.
Berarti di saat testing Chrome aja udah cukup lah ya gitu ya untuk
Chrome Engine.
komputasi
Karena
yang
di banking juga sekarang Internet Explorer udah nggak dimasukkan ke dalam browser yang disupport.
Baik, siap.
Wah, hebat-hebat nih pertanyaannya. Tulis.
Ayo teman-teman, ini mata kuliah PBB ini, ayo tanyain.
Pak Panji.
Dapat A nggak Pak Panji? Pak Panji masih ada nggak sholat ya Pak Panji? Bu Khadijah ada nggak ya? Khadijah ya. Masih ada waktu ya Pak. Menerima mahasiswa S2 nggak Pak Khairul sama Pak S3? Menerima mahasiswa S2, S3, nah ini bisa kita kirim mahasiswa berapa begitu? Masih mute.
Masih mute, Pak.
Oh iya, ke kantor maksudnya.
Yang ngirim
Di
mahasiswa
kantor
kita
itu
ingin.
saya suka ngepost di Facebook atau di LinkedIn, di Instagram
LinkedIn ya
juga.
lebih.
Jadi mereka sekarang lebih sukanya untuk nge-hire itu menggunakan cara hackathon.
Oh, hackathon ya.
Jadi siapapun. Jadi waktu itu pernah nge-help di India, Singapura, sama Indonesia. Tahun lalu tuh saya sempat jadi kayak mentornya. Gitu. Jadi kita lihat dari situ apakah bisa kita teruskan untuk dipanggil interview. Gitu. Jadi itu ada beberapa posisi, ada untuk machine learning, AI, kemudian ada untuk big data, kemudian ada untuk back end, kemudian ada untuk front end, ada juga untuk SRE. SRE itu untuk kayak service reliability engineering itu yang kayak AWS, Docker, dan semacamnya. Kemudian ada juga untuk Scrum Master-nya. Jadi nanti ketika Anda mendaftar, Anda memilih Anda spesialisasi di mana. Nanti kita gabungin dari beberapa orang itu menjadi satu tim. Nah, di satu tim itu nanti ada Scrum Master-nya, ada back end-nya, ada front end-nya, ada SRE-nya. Kemudian kalian nanti ambil satu problem yang kita sediakan. Nah, kalian bekerja untuk men-solve problem itu. Gitu. Nah, dari itu kan sebenarnya kita bisa melihat performance dari setiap individunya kan. Nah, nanti ada mentornya itu nanti yang ngasih tahu oke, si A, si B, si C ini bisa diteruskan untuk dipanggil interview. Itu sekarang sistemnya seperti itu. Jadi
menarik.
Nanti kalau misalnya ada apa-apa nanti ya tinggal lihat di LinkedIn saya atau di Facebook, atau nanti juga saya bisa sebarkan ada acara hackathon. Saya pun masuk bisa diterima di DBS itu lewat acara itu. Gitu. Jadi saya waktu itu gabung juga sebagai developer gitu. Kemudian ya nge-solve solusi, kemudian sudah itu ya dipanggil interview, ya udah, kemudian proses negosiasi dan segala macam posisi dan gaji baru diterima gitu. Dan itu lebih terbukti karena kan kita bisa langsung lihat interaksinya, dan kita tidak hanya menanyakan gitu, karena bisa jadi mereka lagi saat itu nervous atau apa dan nggak bisa ngejawab. Dengan hackathon itu kan jadi natural, ayo silakan Anda kerjain sendiri gitu, kita ngelihat. Jadi dari pagi dari jam 8 sampai jam 5 itu. Untuk Scrum Master-nya pun dilihat apakah dia bisa nggak ngedrive si timnya gitu. Apakah dia bisa ngebuat kayak apa jirat tiketnya, itu ada berapa tiket yang harus diselesaikan. Kemudian kan kalau di sprint itu ada namanya stand up meeting, nah, segala macam kan dia agile ceremony. Nah, dia bisa nggak nge-setup misalnya, oke, kalian kerja nanti dalam waktu sejam, kemudian kita kumpul report progresnya seperti apa. Dari report progress selama 2 menit, 3 menit ada kesulitan nggak, ada apa, ada bisa di impediment, ada blocker nggak, atau apa. Oh ya, ini ada ini. Nanti kemudian udah selesai 5 menit, 10 menit, kemudian lanjutkan lagi kerja. Nanti balik lagi sejam lagi. Kayak stand up meeting. Jadi stand up meetingnya per tiap jam. Kalau kita kan misalnya stand up meeting tiap 24 jam tiap hari kan. Gitu. Jadi si Scrum Master-nya pun dilihat. Kemudian nanti si SRE-nya, Service Reliability Engineering. Jadi dia bisa nggak nge-setup AWS-nya, EC2-nya, database-nya. Bisa nggak dia nge-setup S3 bucket-nya, atau dia misalnya pakai Azure atau apa gitu kan. Nah, biasanya kita sediakan untuk solusi ini kita menggunakan AWS, silakan. Si SRE-nya itu yang harus nge-setup. Apakah dia mau menggunakan EC2 atau Lightsail atau apapun, mau pakai serverless, silakan. Gitu. Nah, si backend dia nge-coding backend-nya, membuat database skemanya dan segala macam. Si front-end dia ngebuat presentasinya. Nah, nanti si 7 orang atau 8 orang itu kerja bersama, kemudian dia ngehasilin hasilnya nanti jam 5 itu dipresentasiin. Gitu. Nah, itu cara yang sudah sangat rutin dilakukan sama perusahaan sekarang. Gitu. Dan ya kalau misalnya itu pun terbuka untuk siapapun, karena waktu tahun kemarin itu ada untuk India, ada untuk Singapura, ada untuk Indonesia. Gitu.
Wah, ide good idea sih Pak. Saya lagi nyari tim-tim juga hackathon ya.
Silakan. Dengan hackathon. Jadi hackathonnya itu dibuat beberapa tim, satu timnya harus ada Scrum Master, ada SRE-nya, ada backend, ada front-end, komplit gitu. Gitu. Jangan semua backend, jangan semua front-end. Nggak akan maju itunya progresnya. Itu jadi harus buat kayak gitu. Nah, dari situ orang baru kelihatan bagaimana interaksinya. Setiap jam kan kita ikut stand up meetingnya, apa perkembangannya. Kemudian dia kan harus membuat source code-nya juga, kita sudah tentukan kamu nanti komitnya di Bitbucket ini atau di GitHub ini. Baru kita lihat, baca kodenya yang mereka tulis.
Kalau ada yang super power gitu, cepet banget, tapi tim pendukungnya tidak support itu, akhirnya
dia bisa ngebantuin. Kalau misalnya dia
ngebantuin.
backend-nya udah selesai tapi front-end-nya masih kurang, ini dia bisa ikut. Ada bisa saya bantu nggak gitu loh. Ada berapa halaman yang belum selesai atau ada berapa komponen yang belum selesai. Sini saya buat. Kan kode repository kan bisa share. Dia buat branch satu, nanti kan bisa di-combine. GitHub, GitLab, Bitbucket, apapun yang mereka mau buat pakai gitu. Nah, dari situ kan mungkin jadi nilai tambah. Oh, dia bisa backend, dia bisa front end. Oh, dia bisa jadi full stack nantinya. Kita buat gitu rekomendasinya si mentor-mentor itu.
Interesting.
Jadi kalau mau gabung nanti lihat aja di Facebook saya atau di Instagram saya atau di LinkedIn saya. Pasti saya Facebook. Oh, ini ada hackathon nih. Hack to hire namanya. Kalau dan saya pun ikut masuk ke DBS gara-gara hack to hire itu. Gitu.
Jadi mulai bakalan banyak nih mekanisme rekrutmen seperti itu ya kayaknya ya, karena lebih nyata gitu hasilnya ya.
Iya, karena kalau misalnya tergantung sama headhunter juga ya banyak lah trade off-nya ya, pro and cons-nya. Gitu.
Mungkin trade off-nya jadinya produk isunya jadi ketahuan gitu, yang mau dikerjakan seperti ini gitu ya.
Ya bahkan ada juga yang tim khusus untuk machine learning. Jadi nanti karena dia khusus machine learning dikumpulin gitu ya. Mereka cuma dikasih problem statement tentang machine learning itu gitu. Ini ada datanya, ada beberapa tipe data gitu. Anda silakan cari modelnya gitu. Jadi nanti dari model itu kita tes dengan tes datanya gitu. Kan mereka dari data itu kan kita siapin tren datanya ini. Silakan Anda membuat modelnya. Gitu. Nanti dari model itu kita tes. apakah sesuai atau enggak. Gitu.
Baik. Terima kasih Pak. Wah, insight-nya mantap.
Sip.
Pak Edi.
Well, a lot of information. Ya Pak, terima kasih Pak Khairul. Ya.
Sama-sama.
I think we have no question anymore. So, Pak Adi, is it okay that we finish it earlier? Pak Adi? Yeah, okay. Well, we've come to the end of this visiting lecture session 2 with Pak Khairul Answar, Ph.D. Maybe you have a closing statement, Pak Khairul?
Kayaknya udah cukup deh, udah banyak tadi.
Maybe ya satu dua kalimat gitu for inspiration.
Mungkin dari apa ya? Dari pengalaman pribadi, menghandle atau ya kan saya ini menghandle dua hal ya, satu academical, yang kedua profesional. Ya, untuk menghandle kedua-duanya itu bukan hal yang mustahil, tetapi memang ada trade-off. Trade-off-nya misalnya saya nggak bisa dapatkan scholarship, ya kan, nggak dapatkan beasiswa karena salah satu syarat beasiswa kita tidak boleh memiliki pendapatan lain, gitu kan. Sedangkan saya profesional kan digaji sama perusahaan. Jadi mau tidak mau saya bayar uang kuliahnya itu sendiri, gitu loh. Dan itu memungkinkan, gitu. Salah satunya itu karena banyak sekolah university itu sekarang udah bisa mensupport the research base. Jadi kita nggak perlu datang ke kampus, kuliah, masuk kelas dan segala macam. Dan ya Anda bisa membayangkan saya membangun kehidupan profesional saya gitu itu di Singapura gitu, dan ya sangat kompetitif, dan itu ya memungkinkan untuk bisa melanjutkan sekolah juga. Yang menjadi pembeda itu adalah komitmen gitu. Setiap kalau kita sudah punya komitmen itu insya Allah bisa banyak dikasih jalan. Tapi memang komitmennya misalnya harus baca paper sehari berapa gitu kan, itu harus kemudian dimengerti kayak gitu. Jadi setelah itu kemudian membuat kayak summary-nya dan segala macam. Itu sih ya, pengalaman itu, kebiasaan tuh bisa sampai tidur jam 2, jam 3, jam 4 gitu. Itu udah selama dari tahun 2010 itu ketika saya melanjut ke master, selesaikan Ph.D itu 2021. Jadi selama 10 tahun ya harus suffer seperti itu. Tapi memang agak lambat di karir profesional saya. Gitu. Itu trade off karena memang fokusnya adalah oke, yang penting saya dapat pekerjaan, saya dapat pemasukan, saya bisa membiayai keluarga saya, tapi saya juga bisa melanjutkan sekolah kuliah saya gitu. Makanya kalau bisa melihat dari profil saya di LinkedIn itu sangat banyak sekali senior aplikasi, senior itu sampai terakhir itu sampai 2020 gitu. Senior associate itu saya masih 2020 karena memang fokus saya harus kerja dulu, harus sekolah dulu, selesaikan kuliah. Nah, kuliah sudah selesai, nah sekarang saya baru fokus karir. Kalau saya mau mendapatkan pekerjaan baru, setidaknya saya harus dapat ada loncatan di jabatan atau di tanggung jawab gitu, level atau destination-nya. Itu jadi membangun karir profesional bersamaan dengan akademis itu sangat memungkinkan, tapi ya harus ada trade off-nya aja gitu. Seperti yang tadi saya ceritakan.
Yeah, thank you very much Pak Khairul Answar for the inspiring sharing and enlightenment for us. for all of us. Well, I think that's enough for this session. Again, we would like to say thank you, Mr. Khairul Answar, Ph.D. Yeah, as your moderator, yeah, I also apologize if any mistaken I've done. Right. Okay, please give a big applause for Mr. Khairul Answar to say gratitude. Okay. Well, I will return to MC, right? Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam wabarakatuh.
Waalaikumsalam warahmatullah.
Thank you, Mr. Khairul Answar, PhD, and Mr. Edi Suharto, STMCom. Before we move on to the next session, we are going to do a short photo session for documentation. For all participants, we would like to have your cooperation to turn on your camera for this session. Taking a picture on my mark. 3, 2, 1. Once again, thank you, Mr. Khairul Answar, PhD.
Sama-sama. Ya, salam semuanya ya. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
And now we will have our short break before continuing to our third lecture by Associate Professor Agustian Taufiq Asyhari, Bachelor of Engineer, PhD, and all participants are pleased to join us again after the break at 1 p.m. Thank you very much.
Cek, cek. Kedengeran suaranya? Taufik kedengeran?
Gimana, Bu?
Kedengar suara? Sebentar. Mas Pak Taufik maksudnya.
Oh, udah Mbak. Gimana Mbak?
Oh, oke. Sudah masuk ya?
Udah, siap.
Siap. Oke. Udah lama banget nggak ketemu.
Betul.
Habis
Gimana
lulus
kabarnya?
kabur ya, habis lulus. Iya,
Gimana kabarnya?
baik. Alhamdulillah. Alhamdulillah baik. Oke, sudah siap. Mbak Feli, sudah siap? Mbak Feli?
Ya Bu, bisa saya mulai sekarang?
Atau ya mulai aja kali ya? Kita mulai sekarang.
Ya boleh. Langsung saya mulai sekarang aja Ibu.
Apa mau nunggu? Tinggal 1 menit ya, nunggu 1 menit aja.
Oke. Okay. Hello, everyone, and welcome. Welcome back to the visiting lecturer of Department of Informatics, Faculty of Science and Mathematics, Diponegoro University. Distinguished guests, ladies and gentlemen, we are proceeding to the third lecture of today's visiting lecturer. For this session, we are very honored to have Associate Professor Agustian Taufiq Asyhari, Bachelor of Engineering, Ph.D., Senior Member of IEEE, Fellow with the Higher Education Academy, a very special guest from Birmingham City University. And the moderator for the second session is our very own researcher, Mrs. Rismiati, Bachelor of Engineering, Master of Computer Science. Without further ado, please welcome Associate Professor Agustian Taufiq Asyhari, Bachelor of Engineering, Ph.D., and Mrs. Rismiati, Bachelor of Engineering, MJS.
Ya, makasih Mbak Feli, thank you. Oke, good afternoon everyone. Selamat siang, selamat pagi ya di UK, Taufiq. Oke, yang terhormat, the honorable speaker for this session, Associate Professor Agustian Taufiq Asyhari, all fellow lecturer from Department of Informatics, Universitas Diponegoro, and also all beloved student from Department of Informatics, Universitas Diponegoro, and last but not least, all participants which I cannot mention one by one. Okay, thank you for joining us in this session. And this session is the third session and the last session for today's visiting lecturer program, which is in conjunction with the second day of ICCOS 2022. And for this session, we have a very special guest from UK, Bule Rasa Lokal ya. He is Associate Professor Agustian Taufiq Asyhari. Today, he will be presenting about the world pioneering 5G connected forest. But before he starts his session, let me read through briefly his curriculum vitae. Okay, let me share with you. Okay, Agustian Taufiq Asyhari, Ph.D. is currently Associate Professor in School of Computing and Digital Technology in Birmingham City University. He received his bachelor degree from School of Electrical and Electronic Engineering, Nanyang Technological University, Singapore. He then pursued his PhD in Division of Information Engineering, Department of Engineering, University of Cambridge, UK. He received a lot of awards. I would not read through all his professional experience. You can read through here, but I will highlight some of his selected awards and grant, which is in total, there are more than 30. Some of the most recent awards that he receives are LGC nomination and Best Research with Public and Third Sector UK National and University Award 2022, and also the Smart Place Award nomination, Connected Britain 2022. And there are still more to read here. His research areas are in the area of information theory and signal processing, Internet of Things or IoT, wireless sensor networks, applied machine learning, statistical data analytics, and smart sensing system. He has more than 70 peer-reviewed publications, which some of them are listed here. If I read through all of them, it will be very long. So let us welcome Associate Professor Agustian Taufiq Asyhari. Taufiq, you will have 60 to 75 minutes as per spoken ya, and the rest will be Q&A. Kalau mau ngomong pakai bahasa Indonesia, monggo. Kalau more comfortable in English juga monggo. Okay, the stage is yours.
Okay, terima kasih Mbak Rismi. Let me share my screen. Okay, I think I need to swap. I hope you can all see my screen and can hear my voice clearly.
Yes, clear.
Okay, thank you very much, Mbak Rismi, Bapak-bapak, Ibu-ibu, dosen dari Undip, rekan-rekan mahasiswa mungkin ya ada di sini ya. Terima kasih. Thank you very much for the opportunity. Today I'm going to actually share with you all like the recent projects that we are completing and one of probably most ambitious project in the UK to build and create. Well, it's difficult to claim, but a lot of people face the first first 5 connected forests. So I just want to share with you like the process we went through, all the challenges, what would be the lesson learned, what would be the technical aspects being involved, how we can actually put all together the teams in multidisciplinary applications together, so we can deliver one of the promise we made to the UK government. Well, quick introductions. Actually, maybe Undip is not too foreign for me because I came from Jawa Tengah. I was born in Temanggung and I grew up there. I did my high school in Yogyakarta. Same as Rismi, actually. We are in the same cohort, and did my undergraduate in Singapore. And finally, I completed my PhD at Cambridge University. Well, at the moment, I'm associate professor and cluster director of VNet cluster at Birmingham City University. I think some of these have been mentioned in my CV. I think the highlight for this today will be the project which I currently did as a research leader, which is the 5G connected forest. And actually, this project gives me a lot of headache and a lot of challenges. And actually, it was very difficult 2.5 years. But I think we managed to pull it out together, and we managed to deliver things that we would not have imagined before. So that would be the personal thought about this project. Quick overview of our university. So we are located in Birmingham. Birmingham is in the central of the UK, England in particular. We are actually in between 2 big cities, London and Manchester. Actually, Birmingham is, if not the second, the third biggest city in the UK. If you watch Aston Villa, so Aston Villa is located in Birmingham. I think at the moment we are constructing the high-speed train station across England, and Birmingham is one of the stations going to be built in terms of the connectivity. And the interesting story is that one of the station will be located just in front of our campus. So our campus will be pretty much connected with the rest of the UK, and that will offer a lot of opportunities around the region, because when we see that there will be new station, there will be opportunity around commercialization, there will be opportunity around potentially improving the service, potentially improving the intelligence within the transport system. So there are a lot of opportunities being created in the region at the moment. One highlight from our university is we have our own test bed for 5G. So we have our own 5G private networks where we can use it to help with research, to help with teaching, and then actually that 5G private network is installed in our lab. So we have exclusive use of the connectivity. We also collaborated with many institutions in order to make sure that this network can realize the potential. So we managed to actually engage a lot of stakeholders from environmental science, from healthcare, from industry, from road surveying industry. So all different stakeholders, they can try and utilize the power of 5G in order to help with their business cases. Yeah, so at the moment, like we are getting involved in, I don't know, maybe about 5 to 10 projects, and one of the big projects that we are about to complete is this 5G connected forest project, which is funded by the UK Department for Digital Media, Digital Culture, Media and Sport. So our 5G network in our campus is built based on British Telecom networks, and it utilizes Nokia infrastructure. In the UK, I think one of the sensitivity is around utilizing the products from China. So in fact, it was made clear during the project that we couldn't utilize any equipment from China as part of the network connectivity. So we have to find like alternative solution to find what will be like an appropriate equipment to help with our research and development. Okay, well, from the university, let me introduce briefly about my research cluster. So we are actually belongs to one of the research cluster in the School of Computing and Digital Technology. Our cluster is called Future Information Networks. We are not calling ourselves a future communication network because we don't want to restrict ourselves to just communication technology. So we are seeing connectivity as connecting dots between various information sources that include how we can process information more efficiently and how we can gather patterns or features or any unique signature from the information. So we are looking information as being connected, and we are actually exchanging information from one place to another from time to time. So we are trying to see the intersection between the traditional networking domain and also the artificial intelligence. I think one of the highlights here is in addition to what we do in fundamental research, we also do the applied research, which means that we apply our knowledge, we apply our technology, we apply our techniques, what we learn from our community to solve challenges around community, around our local community, around our national community, and our global community. I think over the past 1 or 2 years, we have been initiating a number of international partnerships. We are actually also working with one of the universities in Indonesia, University of Gorontalo, I think Gorontalo State University, where we deploy some of this digital technology to help with their conservation efforts. So I'm going to maybe talk a little bit about that towards the end of today's lecture. This is the structure of my cluster. So I'm the director of this cluster. I've been there since the past 2 years or so, and then we have several academics. I think this number have been growing. I think this year we got a number of new recruits. We also have a number of research fellows and associates. We have, I think, more than 10 PhD students as well. So we couldn't list them one by one here. But this is my core team from the beginning, where I was given the responsibility as the cluster director. And we try to diversify the profile of the team. We try to utilize everyone's expertise in order to progress the research around the domain of these future information networks. So we are working across different areas from communications, distributed system, security, high performance computing, to robotics and AI. So we are quite, in a way, we are quite diverse from the team's expertise point of view. Okay, I will start my talk with by showing you this diagram. So this diagram consists of 4 different entities. We have people, we have data, we have things, we have process, and what we are going to see in Industry 4.0, we will see more connectivity. What is massive connectivity being created? Obviously, with massive connectivity, it came with the security risk. It came with a challenge of establishing reliable data communications. With massive connectivity, the promise is that we will be able to harness more pattern, more knowledge, more informations, and maybe we can be more wise with that more information, hopefully. Yeah. So we are seeing this, and obviously this interconnectivity came with a challenge, as I mentioned earlier, and those challenges obviously need to be addressed before we can realize the promise of future connectivity. And all of this connectivity is encapsulated within the framework of the Internet of Everything. So in view of this connectivity, I'm going to now move on to what we are actually joining as part of the UK 5G testbeds and trials program, and that is encapsulated in our project 5G Connected Forest. So back in 2020, I think, UK government launched a funding call across different sectors, industry, local government, and also the university, research institutions, in order to try and test the 5G with a view of unlocking the potential of 5G to help with the local businesses, to help with the local community, to help with the growing the economy. So the question is how can we creatively use 5G to across these different sectors? So there are a lot of project proposal being received by the UK government, and we are being part of those proposals getting funded by the government. So as you can see from this figure, we have several projects across the region, from Scotland to Wales and England, and scattered around the manufacturing infrastructure, and then the rural connectivity, the example of which will be our project, and then the the urban testbed, which is also happened actually in our region, because it's West Midlands is our region. And then we have also the health and social care, we have the creative media, we have the mobility and logistics, we have the telco supply chain, and so on and so forth. So we have this variety of things that people want to see utilization of 5G. We think that 5G just offer a new level of maybe connectivity speed or data rate. Well, if it is the case, then obviously 5G will not be as attractive as possible, because what does that actually mean to the end users? So what we want to see here is that how 5G can actually unlock the potential of the areas where it has limited usage before, where where it has not been applied before, or where it can generate new creativity. It can generate creative ideas around some of the sectors that government are concerned with. And why one of the funded projects will be focused on rural area? The reasons will be, like, if you look at the UK map, obviously we can see a number of regions being fully connected. So the one in the dark purple, they are actually over 50%, can receive 10 megabits. Sorry, it's actually the other way around. The one in purple actually receives less than 10 megabit per second. So it's actually quite challenging to establish the connectivity on region. And then over the past 2 or 3 years, there has been some improvements, so some coverage has been improving. But however, we can still see some of the gaps between the connectivity among different regions. So we try to address some of this connectivity issue by considering not just the current technology like 4G and before, but also the future connectivity like 5G. So how 5G can actually further support this connectivity coverage across regions in the UK. So hopefully after the deployment, we can see more and more area being covered, and more area being fully interconnected with each other. There has been like a survey where this connectivity can actually translate into access to the business, access to the economy, access to the opportunities. Obviously, in order to resolve some of the challenges, we will need the connectivity to be fully in place. But unfortunately, the connectivity always comes into price. Before the UK government is committed to invest in this infrastructure, they will need to see the justifications of that infrastructure development. And part of that justification will be through this test and trials program funded by the DCMS. So we try to convince the UK government to come and invest in the rural area, so that people in the rural area will be able to access to better connectivity. It can provide them with new opportunities from the economy point of view, and it will help them in order to preserve some of the aspects that they may face in the rural area, such as, for example, forest conservation. Okay, so again, yeah, from the rural point of view, I think I'm going to use this forestry as a use case. Actually, I've been covered by one of the Indonesian media, Republika. So if you are interested in reading something maybe a little bit boring, because it's a very long article, you can actually have a look at this article, Melindungi Hutan dengan Robot 5G. So there I share a lot of findings, a lot of challenges, a lot of ideas and approaches in order to help support build the world first 5G connected forests. So feel free to have a look at this article later on after this session. So we also covered in one of the telecom magazines, mobile magazines, and we are actually making to the front page. one of the things that we are working is on the networks and artificial intelligence. We are not treating the two of them separately. We are actually combining the two of them. Some of the researchers in our team, they are working on the networking side. Some other researchers, they are working on the AI, how to leverage the power of this high-speed connectivity, how to leverage the low latency capability offered by 5G in order to help the conservation. What kind of data we want to gather, what will be the time requirement of the data, how we can process those data more efficiently, how we can optimize the sensing technologies, how we can distribute the processing across different devices, and then finally, how we can make decisions based on this data being collected. Okay, so this magazine is also available online. So if you are interested, I put the link of the online versions down here, so you can have a look later on. I think it contains a lot of resources, such as the article itself, but also some interview with across a different number of partners. Okay, so we got these ambitions 2.5 years ago, when we don't think 2 years ago we would be able to achieve these ambitions, but fortunately, I think we are able to pull it out together. Let me maybe just talk with you. I will show you the video later on if I have the ability to play the video. Sherwood Forest is unique in the sense that if you know, like the legend of Robin Hood, Sherwood Forest is believed to be an area where the Robin Hood was based during the medieval period. Okay, so a lot of movies about Robin Hood actually involve Sherwood Forest. Sherwood Forest is an ancient forest, which means that it has been there for decades. It has been there for centuries. And in fact, we see a number of trees have been there for more than, I don't know, 800 or 900 years old. One of the signature of this Sherwood Forest, what we call as a major oak. Major oak has been there for at least 800 years old. It's very, very old tree. It's very well preserved by the UK government. One of the signatures from British people is they like to preserve stuff, so we can see that tree still exists until today. There has been a lot of challenges around preserving this ancient forest, and then we are, from the technical point of view, if you think about IoT solutions, we are not able to do so because we cannot put the sensor on the trees directly. Okay, so we are constrained, we are prohibited to do a kind of changes to the tree. So we have to think about something else in order to protect the forest, in order to make sure that whenever whatever methodology we try to use to protect the forest will not damage the forest itself. Okay. So one of the vision here is to explore the potential of 5G to protect and promote areas of natural and cultural heritage. An example that we are going to use here is the Sherwood Forest, but obviously we can apply the same approach to the other forest. Later on, I'm going to illustrate how we can utilize the AI that we developed in this project to a case in Indonesia. And we are actually currently in the middle of that project, so it's actually quite exciting to see what we can do further with that approach. We have been writing this article in open access journal, so you can have a look at this article later on. So the article is written not fully technical, I would say. It's more like sharing the experience to what we have encountered in this 5G testbed and trial program. So the 5G testbed program in our project, Connected Forest, we have 4 different components here. The first one is the 5G signals in a woodland area, which means that we want to see how the signals can penetrate across different density of the trees. Because the UK has 4 seasons, right? So different seasons will have a different configuration of trees. Sometimes we have very minimal number of leaves. For example, during the autumn period, we will have a less number of leaves, but during spring and summer period, the forest is very much condensed in terms of the trees configuration. And then we also, one of our partners developed a holographic movie. So this movie is about Robin Hood. So one of the ambition is that we try to bring out Robin Hood to life. So not just a character we watch in the movie, but also we try to bring the character live. I have tried this headset. It was quite interesting. It allows the user to interact with Robin Hood characters. And then we have the 5G testbed for environment protection. This is the one that we are actually developing as the research lead of this project. And then the last one is the 5G quadruple robot forest ranger. So we are building the functionalities for the robot. We are not developing the robot from scratch, but we are making sure that the robot is connected to the 5G network. Not sure if I can play this. I'm playing this. Maybe the audio will not be okay. It doesn't seem playable, but I'm going to share later on the slide. So if it is playable, you can watch this video from the slide. Okay. Okay, so now I'm going to talk a bit more about the environmental protection workstream of the projects. And well, you might be asking a lot of questions. Why am I talking about this environmental management? Why am I not talking about, I don't know, IT, networks, data science, and so on and so forth? Okay, we will see the connectivity in the next few slides or so. So we got here the two robots. Actually this robot got names. So the first one, the bigger one is forgot, Gizmo. The name is Gizmo. There was a competition to name this robot, and the second one is named Eric. So we call Gizmo and Eric, and they are tasked to help us to collect the data from the forest and transmit those data closer to real time to whoever will be interested in the data to make decisions. Okay, before talking about Eric and Gizmo in details, I'm going to just provide an overview about why 5G matters, what capabilities offered by 5G, what will be the characteristics of 5G. So we have three different umbrellas of 5G. The first one is the massive IoT. So this is just like an extra development of the IoT that we have seen today. We have like a different standard to support IoT in 5G. One example will be LTE-M, evolutions of the current standard for LTE for mobile. We also have the NB-IoT. So all those different technology will help us to improve or to provide interconnectivity among massive number of sensors. The second umbrella will be the mission critical control. This is very important for applications where it requires low latency communication. An example of which will be autonomous systems such as self-driving cars, autonomous systems such as drone, autonomous systems such as robots. They all need this mission critical control in their kind of architecture. And then the last one is obviously the enhancement of the 4G. So enhanced mobile broadband. The target will be a few gigabits per second. However, we are still a bit far from the target. The test that we have done so far with our 5G network can reach up to 500 to 700 megabit per second. So we are still having a shortage of about 400 to 500 megabit per second. Jadi di sini ini ya apa namanya kita combine these different characteristics with within the 5G, and we try to offer this characteristic to help execute data processing, to help transmit the data, to help process the data, to help what do you call it? To help with the intelligence processing of the data. Okay, so this is the kind of a simplified architecture to the system that we have developed. So we have like a forest here. We assume this is a forest. So in the forest, we may have a lot of events. One of the events will be maybe like some fires may be happening on the forest, or we may be seeing some of the storm affecting the forest. After this event, usually what happens is that the forest will be damaged to some extent. So either the tree will be falling down, or the tree will be damaged by the fire. There may be people getting lost in the forest, and they will need some rescue. So we need to gather as much information as possible from the forest in order for the stakeholders, for the forest management to make decision about what we need to do next. Okay, so in order to do this kind of data gathering, as I mentioned before, IoT will not work here because we are not allowed to do that installation of sensor across trees. We are afraid to damage the trees if we do that. So we do what we call as remote sensing. And we do this remote sensing through two different autonomous devices. One is the robot and the other one is the drone. We try to obtain the whole view of this forest by leveraging the data collection process from these two technology. And then from this drone and robot, what we are trying to do is we try to connect them with the cellular networks, particularly 5G, so that we can transmit as much data as possible at least time as possible. So here we have a variety of possibility. We have a possibility that the drone can transmit data directly to the stations. We also have the possibility that the drone can transmit the data first to the robot, and the robot can forward the data to the station. The reasons why we consider these two options is because 5G utilize different approach compared to 4G. In 5G, the base station antenna size is very small. So it's not like a big tower we have seen for 4G, 3G, and before. So 5G base station is very small, and in fact, some of this base station can be installed in lamppost. So it's very small base station. The problem with this small base station is that the coverage it will offer is quite restricted. It's probably within a few hundred meters or so per base station. Which means what? Which means if we only have one base station, we may only have limited coverage for the 5G because it utilizes like high frequency transmission. So in order to extend this connectivity, we explore this possibility of transmitting the data first to the robot, which can be through Wi-Fi if we are still within the Wi-Fi coverage of this robot access point, or through 4G if we still have 4G connectivity from the drone to the robot. What happens if we don't have the connectivity? Okay, and it happens a lot during our trial because obviously the rural area has challenges in terms of connectivity. So if we don't have the connectivity, what we are going to do here is that we save the data first, and then whenever the drone flying closer to the base station, either this base station or either the robot, they will offload the data. So the challenges of scheduling the transmission will be important here because we may not be able to transmit every time. So we have to make sure that we have proper control of combining post-transmission, post-computations, transmission and computation, and so on and so forth. So I'm going to share some of the technical details of this in the next coming slides. Yeah, so the first thing that we are doing in this, as you can see from the environmental sensing slide here, is about the robot. So the robot we use is the robot purchased from Unitree. So they have different types of robot, and the one that we use is the robot dog. The reasons why we use robot dog is we want the robot to be able to move to difficult terrains, the forest. So wheeled robot, like the robot that we have seen in the hospital setting, will not be able to accomplish this objective. So we have like a researcher working on this robotic functionality development, robotic control, and we also change the configuration of this robot so that we can interface the robot operating system with the 5G connectivity. Okay, so we have this capability. We also incorporate a number of sensing techniques such as sensing from the RGB camera. We also have the capability to look at the depth camera as well, so we can actually see the distance between the object across a different range, and that will be indicated into different types of colors. We can also carry out almost real-time object detections for any objects that we are interested in detecting. We also managed to program the robot to follow certain objects. So for example, like if you want the robot to follow a person, the robot can actually be programmed to follow that person using this visual sensing capability. Based on the sensing that we develop, we also have the option to install the robot with the capability of detecting tree species. So when it collects the data across the forest, it can immediately detect the trees directly close to real time, rather than just collecting the data and giving it back to the stakeholder. The second functionality that we develop is the forest manager. So this is more about the decision making made by the forest management. In order for this management to be able to make decision, we are giving them with the capability of accessing another source of information, which is taken from the unmanned aerial vehicle or drone. So here we have the drone purchased from I think Austrian company, Air6 drone, can carry quite a heavy payload. It can carry, like, actually, if you look at this, is like the LSR camera. So we can use this drone actually to capture high quality images, and we can also carry out close to real-time object detection using the drone. Perhaps for some of you who have been working on machine vision and machine learning, you may be familiar with the YOLO framework. We are utilizing a YOLO framework for the real-time machine learning deployment. We utilize to detect fires. We utilize YOLO to detect different objects across the forest. And our focus is actually not to develop the AI algorithm itself. Our focus is on testing the latency of these algorithm executions on the real world environment, especially in the context of the forest in this case, because the latency will be quite significant in an area where the network connectivity is not stable. So this is what we want to test. This is the one that we want to see what will be the improvement offered by 5G. This is the illustration. I'm not sure again if the video can play. Okay, I think I have issue with the audio and video this morning. So I just want to highlight here is that we actually doing some kind of testing program. Okay, so this video is recorded video because obviously we cannot burn the forest to test our capability, right? So we have to utilize other means. So what we do is that we got a video that we obtained from existing public resources. We download that video and then we broadcast the video through UAV or drone in real time, and we try to do this detection in real time. So this detection happens in real time and happens across the 5G connectivity in the forest. So we try to measure the latency of this detection, the latency of the data transmission, as well as the end-to-end latency. We know that for emergency events such as fires or a storm, for example, being able to detect events quickly and rapidly is very, very critical for stakeholders to make the decision about what needs to be done next, what kind of intervention measures that need to be in place, because this kind of emergency events might translate into the life of individual. So it's very critical to be able to do this quickly, close to real time. This is again simplified architecture. So what we do, we utilize two types of camera, in this case RGB camera, thermal camera, and then we do this object detection segmentations. We have the options to process this detection in local servers, cloud servers. We can see a lot of challenges here: limited coverage, intermittent connectivity. We are in a rural area, so even though we have 5G basically installed, the connection is not so stable. So that impact the reliability of the AI algorithm. Some of the data we receive are corrupted, so we have to make sure that the algorithm is robust about that data corruption. Energy constraint, this is actually a very big problem because we know that almost everything here, they are battery powered. So we got the drone, battery powered. We got the camera and processor inside, which we equip the drone with. They are battery powered. We got the local server, which is basically our laptop, is battery powered. Well, we have cloud server, which is located far away, which is not battery powered, obviously, but we typically assume this as something given to us. So here we have a lot of appliances utilizing battery. Then obviously with battery, we have limited lifetime. And the more transmission we do, the more processing we do, that will shorten the battery life more and more. So we are actually having this problem of energy constraints. And because of that, some of the problem we encounter is not because of the transmission or not because of the processing, but because of the short battery lifetime. So innovation in battery is very critical here. And actually, I look forward to hearing more ideas from maybe from stakeholders who are actually doing battery research, how we can actually expand or extend the lifetime of the drone. Okay, and then we have an options to build time series data from this data collection, so we can see the changes of the environment from time to time. We can compare the differences, and if we detect those differences, we can actually inform the stakeholders so they can make take actions against those differences. Those differences can be something to do with the emerging event, but those differences can also be something to do with the invasion of the non-native species in the forest. So non-native species in the forest are threats to biodiversity in a given environment. So it's quite important for the stakeholder to know this non-native species invasion. Okay, I'm going to talk maybe a little bit about the the proposed solution that we are doing in this project. So as I mentioned earlier, we have the capability of sending the data directly to the base stations. If we have 5G coverage, if we don't, we try to utilize existing network from that is available in the forest, and that existing framework will utilize the relay. So we can use the robot as a relay. We can also use the drone as the relay. Yeah. Okay, well, obviously from this relay problem, we have a lot of research questions. One of the questions would be, because we want to do object detection, and object detection requires machine learning. The big question is, are we going to run the machine learning in the cloud? Which means that we have to offload all the data, all the collected data to the cloud, which is quite heavy in terms of the communication requirement. Or are we going to execute the data locally? Okay, which means that we have to rely on the local battery power in order to execute the algorithm. And actually, we can actually do the cooperative computations between the cloud and the UAV and try to find the optimal configurations to minimize the battery consumption and delay. Yeah, so there has been like an algorithm we are utilizing, and we are actually about to submit a paper about those algorithms. Some of these algorithms rely on evolutionary process, and we can actually look how the evolution of the computation can help in optimizing the battery consumption and delay. The algorithm can also look at the optimizing tasks. So rather than executing the whole algorithm in one station, we can actually distribute the computation. So some of the tasks will be executed locally, some of the tasks will be executed remotely. So we can find the optimal task length in which the overall computation distribution will be optimized in terms of battery consumption, in terms of accuracy, in terms of delay. So we have different parameters to optimize. This is something that we have published in one of the conferences in 2020. So you can have a look at this if you're interested in this area. We also look at exploration of data parallelisms and pre-processing model in order to mitigate errors, in order to mitigate missing data due to the intermittent network connectivity. So we carry out a lot of different experiments to make sure that whatever the data we are missing for the machine learning to execute, we can actually compensate that either through interpolation or either through eraser correction. This is just like a configurations where we show how we can optimize the task length. So we have like the end devices like D.Eng here, and then we have the cloud devices here, and then we have the intermediate devices which can be coming in the form of UAV or robots, and we can have a look at what kind of task length we can leverage to execute in every level of the devices. Another thing that we are looking at is on the search algorithm. Suppose that during these emergency events, we find that a person might be trapped in the area. So we have to find that person in order to provide an appropriate rescue activity. So we look at how we can develop search algorithms. So what we do is we look at developing the search technique using the recursive Bayesian estimator. So we try to estimate the probability of finding victims based upon the location of the victim itself. So what we do is that for the whole area of the forest, we divide them into grids, and each grid will have the probability of the victim being localized there. So for example, if there will be a team of rescuers visiting that grid, it will check whether the victim present in a given grid or not. Obviously, once they visit and they discover that the victim is not there, they will need to update their probability of finding the victims across the whole area. So the probability will change from time to time, and different search and rescue team, they will be able to inform each other about their own probability map. So by exchanging this mapping, the rescue search and rescue time can be much shortened in order to avoid like duplications of the visit to the same grid by different rescue teams. I think the last area that we work is on the health of the forest sensing. So we are looking at how we can utilize all these different visual sensors, cameras, to detect the health status of the forest. So if you look at the leaf year, actually the leaf year, we can't tell the differences sometimes, right, from our visual inspection. But we can use other type of camera, such as the multispectral camera, using this NDVI index to tell whether the tree, a given tree, is in a healthy status or in a stress status. So NDVI coefficients will be able to tell us whether a given tree is receiving sufficient nutrition, is receiving sufficient water, and being able to grow according to the nature, according to the natural growth. Whereas another type of tree, because of maybe climate change, because maybe of some kind of intervention which people do in the forest, they may be stressed out. So we can see the NDVI coefficients to be much less compared to the trees that are in a health state. Okay, this is just like some picture we took from our trial activities, so we can see. Well, the forest in the UK, maybe if you have seen the forest in Indonesia, it's quite different. So perhaps we can actually call it the forest in the UK like a park, yeah, like an extended park. Forest in Indonesia is much more challenging because they are very dense. There is not much area we can move. So the data gathering processes will be much challenging compared to the forest in the UK. So we can identify different types of the tree using this object detection. We can also identify deadwood. We can also identify, this is actually indicating the distance of the three objects. The light color indicate that the distance is a bit far away. The dark color, like the red color, this indicates that the distance is actually closer to us. So even though this is like 2D representation, we can actually approximate the locations of the object using the depth camera. So we have a variety of camera which we have explored, and we have managed to connect using 5G connectivity so that the data can be transferred from the field to the station. Okay, maybe one last thing before I conclude my talk, just aware about the time. What we have learned from Khairul Forest, we can actually carry over to Indonesia. So I was part of this consortium between Birmingham City University, University of Tokyo, and Universitas Negeri Gorontalo. So what we are doing in Indonesia Forest is to do the bioenergy resource mapping. We try to understand what will be the potential hidden in the forest for us to utilize the resources for bioenergy development. Well, the idea was driven by the net zero initiative. So we want to have as many as possible the energy resources from the green sources. Unfortunately, in Indonesia, I think the movement is taken through the directions of oil palm plantations. The problem with oil palm is that well, it's coming from the trees, yes, but in some of the areas, actually, it promotes deforestation. So the native trees of the area are getting less and less because of that deforestation. So what we are trying to do here is that we're trying to see if we can find native tree species from the forest, which we can then use that native species in order for us to cultivate the energy, the bioenergy plantation. So we look at the case of Indonesia. We look at Gorontalo. Why Gorontalo? Because Gorontalo is located in Wallacea region. So if we learn during our school days, perhaps we know like Wallacea region is an area where it has unique biodiversity spots. It is a combination between the used to be Asian continent and the used to be Australian continent. They combine together to make like one island. And then because of that, we can see some of the species not being found elsewhere in the world. So we look at this Gorontalo and we actually try to expand the area in Malaysia. So we actually have like some trials in Mataram, Nusa Tenggara towards the end of the year in order to carry out more trials in detecting some of these necessary objects from the forest. And then we also communicate these findings to the local government so that they can inform the populations, the farmers in particular, to cultivate some of the trees, some of the plants which have the high potential in terms of bioenergy. So this is what we are doing. So we are detecting trees, but we are focusing on trees that have the bioenergy potential. So we look at sugar palm, aren, we look at clove, we look at coconut. So all these trees, they are not the planted tree. They are trees that are growing wildly in the forest. So we try to utilize the native trees, not the trees that are being planted by people. And then we try to detect the types of the tree, and based upon the input we got from the University of Tokyo and Gorontalo State University, we want to estimate the biomass provided by each tree. Using this biomass information, we'll be able to create 2D maps that shows the potential of the bioenergy. So this map can be used by the government to make decisions, can be used by energy businesses such as Pertamina or PLN in order to invest in the infrastructure to harness the bioenergy resources from the forest. Okay, I think, I'm not sure, I think I maybe slightly about the time to conclude, just 2 minutes before 55 minutes, I guess. So thank you very much. We'll be happy to answer any questions that are coming out from the audience. Thank you.
Okay, thank you, Taufiq. Okay, if you have any question, please feel free to drop in the chat box or you may raise your hand. You can speak in Indonesia, boleh in Indonesia ya, nggak harus in English.
Boleh. Siap. Boleh bahasa Jawa, boleh juga.
Silakan kalau ada yang ingin bertanya tentang materi hari ini ya. Sambil nunggu mungkin ya, ini berarti ini kalau hutan-hutan kayak di Kalimantan gitu masih susah ya kalau.
Ya, jadi ini ya, kalau yang pengalaman kita kalau di Gorontalo itu untuk capture datanya tidak ada masalah, jadi bisa. Cuman kalau problem untuk capture data kalau di Sulawesi itu kan konturnya kan miring ini ya, sangat steep gitu ya, sangat sangat curam gitu ya. Jadi data koleksinya kan kalau drone terbangnya seperti ini kan otomatis ada ini kan, ada inkonsistensi di pixel density ya. Jadi kualitas datanya itu beda dari satu titik ke titik lain. Jadi kita harus pakai transformasi dulu itu agar pixel density-nya konsisten gitu ya. Terus kalau untuk bisa proses in real time belum bisa kalau di hutan di Sulawesi karena tempat site yang kita kunjungi. Jadi kemarin bulan Juli Agustus kita ke Sulawesi, terus kita pergi ke site. Nah di site itu tidak ada signal sama sekali, bahkan 4G nggak ada. Jadi yang mereka punya adalah konektivitas berdasarkan satelit yang itu cuma sekitar berapa ya, 0,6 megabit per second ya, jadi sangat lambat, tidak mungkin untuk transmit ini secara real time. Jadi untuk real time masih challenging lah untuk daerah itu. Tapi untuk data collection dan untuk memproses datanya itu sudah bisa dilakukan. Yang kita lakukan juga untuk ini adalah kita develop interface yang itu sedang dilakukan sekarang sih, agar orang-orang kehutanan mereka bisa menggunakan interface ini tanpa harus belajar AI atau belajar detail tentang algoritmanya, enggak. Jadi mereka punya interface yang dimana mereka bisa memasukkan image-image yang mereka koleksikan itu bisa dimasukkan di interface itu dan bisa produce result yang bermacam-macam. Jadi mereka nanti punya kapabilitas untuk berinteraksi dengan sistemnya itu tanpa harus tahu sistemnya sendiri.
Oke. Ini ada yang bertanya dari Pak Setia. What do you think about LPWA technologies as LoRa and Bayut? Is it can be compared with 5G in case of rural area? Is 5G will replace that technology? Di chat ya.
Okay. Yeah. So I think LoRaWAN is kind of a de facto standard for today's IoT, and is actually widely used, especially because of the distance, especially because of the coverage offered by LoRaWAN. Usually we call LoRaWAN to make sure that it captures the possible network connectivity across the devices. Yeah, so it's possible. It's going to be, I would say it's not going to fully replace. I think LoRa will always have a special function, especially to transmit something of low data rate. So we can utilize LoRa. However, to transmit high data rate, I think LoRa will be struggling. I'm not too sure to what extent one of the 5G standards. So 5G actually, as I mentioned earlier, it has 3 different main components. The first one is the massive IoT. The second one is the mission critical control. The third one is the enhanced mobile broadband. Obviously, LoRa will not be able to provide the enhanced mobile broadband. LoRa will not be reliable to provide mission critical controls. In that case, 5G will be there to support these components, these characteristics. On the aspect of massive IoT, I think LoRa will work hand in hand with the standard offered by 5G. So in 5G, we'll have the LTE evolutions of the mobile devices, which is focused on these low rate sensors. However, as the experience told us, actually, this thing I obtained from the other consortium in the 5G test bed and trial program. As much as they want to promote the LTE-M standard in the development, it's quite difficult because majority of the IoT devices at the moment, they are based on LoRa. So it's actually very difficult to replace LoRa directly because of the wide deployment of LoRa. So in my personal opinion, I think LoRa will not be fully replaced by 5G. It will be working hand in hand with 5G. So there will be like an ecosystem where LoRa and 5G standard will coexist and deliver the objective together. I think that's my personal prediction.
Okay. Mr. Ade Setia, I hope it answers your question. Okay. Maybe other participant would like to ask some question. Mungkin langsung dari teman-teman mahasiswa juga boleh. Masih pada ngetik. Oke.
Ada pertanyaannya di chat itu?
Does UAV need something like edge in communicating with the cloud?
Well, yes. So what we do is when we purchase UAV, or any of us we purchase UAV, usually it comes with its own system, operating system, control system, and so on and so forth. And usually we are not allowed to access those systems directly by us because it is the property of the manufacturer. So what we did in our project is, instead of looking at their internal system, we considered portable computing power, computing machine in the form of I forgot the term. Okay, I remember now. Single board processors. Okay, so an example of that would be Raspberry Pi, but we also consider another processing tool like NVIDIA Jetson. So we consider these two processors, and then we utilize this processor to provide us with the interface between the camera or the sensing part and also the connectivity part. Because at the moment 5G dongle has not been in the market, right? So we have to find a way to provide this connectivity without having to rely on the dongle. So what we do is that we try to interface these single board computers, processors with these 5G devices that we got from our network operator, and then we also interface that with the camera. So in a way, single board computer, the basic functionality will be a facilitator for data transfer. However, because this single board computer, some of them have quite substantial processing capability, we can also consider this single board computer to do the edge processing. For example, it can do like a data cleaning on the image we collected. It can also to some extent, you can also make a decision to detect quickly about the object, but obviously the accuracy is not too high because of the low complexity of the algorithm. So in a way, we can treat this processor being attached to the drone as an edge device, which actually communicate to the cloud through base station. So the answer to your question, yes. So the idea of the drone carrying out the processor is to provide the edge capability to the UAV.
Okay.
I think there are other questions as well from the chat.
Yeah. Do you think these 5G connected forest will last long because technology improves fastly? And if the answer is no, what will seems to be the replacement of this idea?
Okay. I think it will be at least 3 years. It will be there. So I think the project is actually a good example of working between among industry, government, and university. So the needs of having 5G installed in that area was coming from the government, from the local government. So they really need like the connectivity in the area because it helps with the forest conservation. It helps with the visitor economy. So as perhaps you remember from one of my slides, one of the things that we do, I didn't talk much about here because it was done by another partner. It was the holographic movie, Robin Hood movie. So if we talk about this holographic movie, it offers another perspective about deploying this technology over the forest, right? Because with the 5G, we can create this interaction, we can create this new experience to be offered to the visitors. So we'll attract more and more visitors to the forest. So it will help with the local economy. So at least the government, the local government, Nottinghamshire County Council has committed at least 3 years, the 5G connectivity will be in place in the forest. What happened after 3 years? We don't know. If things are working really well, then obviously the government will consider the expansions of the 5G coverage in the forest. If the new technology coming in, for example, 6G, maybe like the early part of 6G will come in, then obviously we'll need to upgrade the 5G to 6G. So technology always evolves. The 5G here offers as an enabling platform. So if this enabling platform has changed, then obviously we have to upgrade. The main problem with the upgrade is the cost. So anything here, all the things that we have, good ideas, convincing ideas, creative ideas, they may be good, But if it is too costly for those ideas to get implemented, then obviously no one wants to buy those ideas, right? So part of the things that we do here, why we do it this way is because of like trying to save costs in terms of the forest conservation. Currently in Sherwood Forest, what they do for forest conservation is pretty much manual. So they have to hire like conservation specialists to go to the forest, collect the data from the tree individually, one by one, and it will take them days to complete those activities. And because of that, some of the areas have not been covered. It introduces a lot of problems in the consistency of the data. So to some extent, 5G will try to address that problem. It will not be fully perfect solution, but I will say this is the best connectivity that we can get for now, and we will see in the future. I think technology will change, and we will just need to keep us updated with this technology evolution. I think that's my answer.
Okay, I hope it answered Rizky Fajar Satria question. Okay, the next one is from Rizky Akbar. How does AI work to detect objects from cameras? Does it require a complex algorithm? Okay, the students are mostly from the first year of our department, so yeah, it's still not there.
Okay.
Okay.
Oh, sure. Okay. Mungkin gini ya, jadi AI, AI itu artificial intelligence. Jadi ada term artificial, which means that we create the intelligence. Human has also intelligence, right? We have the capability to learn. We have the capability to recognize people based on name. Yeah. But before, if we think about the first time we try to learn about some knowledge, we need to go through some kind of training, right? Before we can read A, B, C, D, or A, B, C, D, gitu ya. Kita harus diajari sama guru gitu. Waktu Ph.D. kan kita diajari itu A, B, C, D supaya bisa membaca ya. Jadi gurunya harus ngasih tahu dulu, oh huruf yang bentuknya seperti ini itu A, huruf yang bentuknya seperti ini itu H gitu ya. Jadi sama juga dengan AI. Jadi AI itu algoritma yang kebanyakan berdasarkan training. Ada juga yang tidak berdasarkan training. Tapi untuk mempermudah penjelasan ya. Jadi algoritmanya itu harus diberikan training dulu gitu. Jadi misalnya untuk objek itu kita ambil algoritma gitu misalnya, teknik gitu ya, disebutnya AI teknik gitu ya. Nah, algoritma tersebut itu kita kasih training. Kasih training itu artinya kasih sesuatu yang kita sudah tahu. Jadi misalnya kita ingin mendeteksi tadi tree species gitu ya, misalnya berdasarkan daun. Jadi yang kita lakukan adalah kita koleksi tuh daun-daun dengan atribut labelnya. Daun ini, gambar daun ini itu adalah pohon akasia misalnya. Daun pohon ini adalah pohon kelapa misalnya gitu ya. Jadi data-data itu kita susun semua, gambar-gambarnya dari orientasi yang berbeda kita kumpulkan semua, terus kita kasih ke algoritmanya agar algoritmanya itu belajar tentang fitur-fitur di data tersebut. Dan bagaimana mereka belajar? Mereka belajar dengan cara kita kasih tahu, oh, yang gambarnya seperti ini yang akaksia, gambarnya seperti ini kelapa gitu ya. Jadi itu yang kita sebut sebagai supervised learning. Gitu. Jadi itu yang kita gunakan di sini. Kita koleksi data itu semua, terus kita training algoritmanya, dan algoritmanya itu nanti setelah kita training, kita tes di hal yang baru, kita ukur akurasinya gitu ya. Jadi tadi di beberapa contoh misalnya mendeteksi kebakaran ya tadi fires gitu ya. Itu kita training juga, dengan image yang mungkin jumlahnya sekitar ribuan ya, agar algoritmanya itu robust gitu terhadap kemungkinan yang berbeda dengan objek yang sama. Jadi itu prinsipnya kita memakai, memang algoritmanya kompleks, itu tergantung pemakaian sih. Jadi kalau kita memang pengen spesialisasi di AI, ya kita harus melihat dalamnya algoritma seperti apa, dan kita bisa melakukan improvement terhadap algoritmanya. Misalnya algoritmanya bisa lebih ringan, atau lebih less kompleks, atau lebih bisa accessible. Tapi kalau kita fokusnya hanya ke applied research, artinya kita ingin dapat apa dari algoritma tersebut, ya kita hanya fokusnya pada tadi training, understanding performanya, terus baru kita ketika kita deploy kita tahu benefits and weaknesses dari algoritma tersebut, gitu ya. Jadi kalau challenge untuk trainingnya itu yaitu banyak banget data yang harus kita koleksi, dan proses trainingnya bisa lama, bisa tergantung mesin kita, bisa sehari 2 hari, atau bisa juga beberapa 30 menit sampai 1 jam kalau misalnya kita punya powerful mesin dan kita punya parallel training, gitu ya. Jadi prinsipnya mungkin algoritmanya memang kompleks, tapi tapi apakah algoritma kompleks itu kita takut menggunakan atau tidak, itu tergantung keperluan kita. Kalau keperluan kita meneliti algoritmanya, ya kita harus ke dalam algoritma tersebut. Tapi kalau kita hanya memakai algoritma, ya kita fokusnya tadi mentraining algoritma tersebut supaya belajar untuk mengidentifikasi objek-objek yang perlu kita deteksi. Mungkin gitu ya.
Ya, nanti juga dapat, tapi masih nanti. Oke, selanjutnya ini ada pertanyaan dari Pak Panji. Pakai bahasa Indo nggak apa-apa. Bagaimana dengan kepemilikan data itu tadi yang UAV terbang di Sulawesi ini, apa dimanfaatkan untuk pemerintah Indonesia untuk riset atau open dataset?
Untuk open dataset masih menunggu publication papernya, masih on the way. Untuk sharing ke pemerintah Indonesia, ya sudah ada plan. Jadi waktu kemarin ke Sulawesi kita sempat audiensi dengan beberapa kepala daerah, ya, salah satunya Pak Bupati dari Gorontalo, gitu ya. Jadi karena Pak Bupati background-nya juga akademi, ya, profesor, gitu ya, sebelumnya, itu sangat tertarik tentang hasil riset kami dan langsung menagih, gitu ya, berapa lama nih akan ketahuan mana spesies yang punya kandungan paling banyak dan seberapa banyak. Nah, ketika beliau mengetahui hal tersebut, itu beliau akan mencoba mendorong ke masyarakat petani untuk membudidayakan tanaman tersebut, gitu ya. Kalau sekarang kandidat terkuatnya lamtoro, tapi kita masih menunggu hasil lab dari Tokyo, ya, untuk melihat potensi lamtoro dari sisi biomasa, terutama lamtoro yang dari Sulawesi apakah berbeda, gitu ya. Karena kalau sekarang, kenapa itu jadi concern, karena sekarang di Gorontalo terutama itu kan komoditas paling utama kan jagung, gitu ya. Nah, problem dari jagung adalah masyarakat atau petani itu banyak menebang hutan, jadi hutannya itu digantikan oleh tanaman jagung. Yang itu tuh sebenarnya kurang baik karena seperti tadi dibilang, Sulawesi itu konturnya itu miringnya terlalu curam, gitu ya. Jadi kalau hutan-hutan yang natif itu digantikan oleh tanaman agraria komersial seperti jagung, itu bisa jadi mempromosikan bencana untuk terjadi, kan, kayak longsor, banjir, dan sebagainya, gitu. Jadi pemerintah lokal punya concern terhadap itu, dan mereka menunggu juga sih hasil dari riset kami, gitu ya, untuk inform polisi mereka tentang tanaman ini, gitu. Jadi mungkin tahun depan kali ya kita sudah bisa melihat hasilnya secara lebih gamblang lagi, gitu.
Oke, gitu ya Pak Panji. Semoga menjawab. Oke, selanjutnya dari Pak Ade ini, apakah pernah menemukan kendala saat mengumpulkan dan mengolah data dengan berbagai obstacle yang ada? Mohon saran juga apa yang harus dilakukan jika menemui hal tersebut.
Oh ya, banyak. Datanya banyak. Tergantung sih, ini kalau konteksnya yang kami lakukan di UK, mungkin kendala terbesar Kendala terbesar ini akses untuk collect data, karena lagi-lagi ini kan ancient forest, gitu. Ancient forest, we have difficulties in accessing the forest, gitu. Jadi permission-nya bisa lama, dan ketika kita mau doing research within that ancient forest, we need to get like a permission from different stakeholders. It can take like 6 months to get permission. Jadi that is one of the main difficulties. Kalau di UK, problemnya adalah musim. Jadi di UK itu kan ada 4 musim. Musim semi, musim gugur, musim panas, musim dingin, gitu ya. Beda-beda musim itu hutannya itu beda bentuknya gitu ya. Jadi ketika kita sudah tadi men-training algoritmanya berdasarkan waktu tertentu, itu nanti ketika kita mau tes di waktu yang lain itu kadang akurasinya kurang tinggi gitu. Karena apa? Karena bentuknya sudah beda gitu ya. Musim gugur kan daun-daunnya rontok tuh. Terus kalau musim musim dingin hampir nggak ada daun. Terus musim semi baru daunnya tumbuh lagi. Itu kan beda-beda. Jadi kita punya kendala di situ gitu loh untuk tes algoritma tersebut pada musim-musim yang berbeda gitu ya. Nah, karena hal tersebut kita harus mencari alternatif lain bagaimana kita bisa mengidentifikasi spesies tersebut dengan misalnya pakai signature yang lain, misalnya dari batangnya atau dari bentuk pohonnya secara umum dan sebagainya gitu ya. Jadi kita harus berpikir cara apa gitu ya, harus berpikir kreatif cara untuk bisa mengumpulkan data secara tidak langsung. Nah, kalau di Indonesia problemnya adalah kan yang melakukan data collection bukan kami ya, bukan dari computing sama data processing expert ya. Jadi yang mengumpulkan data kan dari rekan kami di Indonesia di Gorontalo yang mereka punya expert di forestry conservation gitu ya, dari orang kehutanan, orang biologi sama kehutanan. Jadi problemnya adalah data yang mereka kumpulkan kadang-kadang itu tidak match dengan data yang kita perlukan untuk men-training algoritmanya gitu ya. Atau ada banyak data yang kurang gitu. Jadi banyak proses data collection itu jadi kurang efisien karena harus sering-sering kembali ke hutan lagi gitu ya untuk mengambil data tersebut. Dan travel ke hutan itu kan sangat intensif sekali gitu, sangat memakan waktu, sangat mempersulit dan sebagainya gitu. Jadi ya itu salah satu ini sih yang kita belajar bahwa kita kalau bekerja multidisiplin itu memang kendalanya banyak di mensinkronkan apa yang kita inginkan dari sisi kita, dari disiplin kita dengan apa yang orang lain lakukan. Nah, ini mungkin jadi lesson learned juga untuk misalnya kita mau working dengan forest conservation people gitu ya. Jadi ini salah satu mungkin capacity building yang akan kita lakukan nanti bulan Januari ya dengan rekan-rekan stakeholders di Malaysia, terutama yang peneliti-peneliti untuk kehutanan, agar ketika mereka working dengan people dari background digital, mereka tahulah kira-kira apa sih yang diperlukan untuk mendapatkan data yang memadai lah untuk memproses secara digital.
Oke, gitu ya. Tadi sebenarnya jadi penasaran. Tadi kalau musim itu berarti tetap pakai satu algoritma. Untuk 4 musim itu tetap algoritmanya sama?
Algoritmanya sama, cuman parameternya yang harus berubah gitu.
Oh, yang harus berubah.
Parameternya harus berubah ya, betul.
Berarti update tiap musim update gitu nggak?
Iya, seharusnya seperti itu. Atau kita, ya, karena kita tidak bisa melakukan testing ke 1 tahun penuh. Jadi ketika kita melakukan testing itu kita sudah pada fase bulan Mei atau Juni tahun ini. Ya, kita baru bisa melakukan fully testing itu baru Mei Juni tahun ini karena untuk install networknya kan butuh waktu. Ya. Jadi kita tidak punya kesempatan untuk merekam banyak data gitu. Jadi kita punya waktu cuma 3-6 bulan. Jadi itu cuma mengcapture musim-musim semi sama panas gitu kan. Nah, kalau untuk dites sekarang yang sekarang ini daun-daun mulai rontok, ini agak susah itu karena sudah beda, kita harus collect data lagi gitu kan. Jadi kesulitan di situ. Tapi kalau untuk yang batang tadi, yang deadwood dan sebagainya itu bisa dilakukan tanpa harus collect data lagi karena kan bentuknya kan more or less sama, paling cuman light exposure aja yang berbeda. Karena kalau masa-masa musim gugur sama musim dingin kan malamnya cepat ya, malamnya lebih panjang. Jadi light exposure-nya kan kurang banyak gitu ya dibanding musim panas atau musim semi gitu. Jadi di light exposure aja, dan kita sudah melakukan testing untuk light exposure dan algoritmanya cukup robust sampai gelap sekali gitu ya, cukup robust gitu. Itu yang kita temukan di testing.
Oke, siap. Ini satu lagi dari Rizky. Menurut Bapak, apakah ide ini mungkin digunakan untuk memonitoring hewan langka atau dilindungi oleh pemerintah Indonesia?
Iya, bisa. Ya, jadi ini sekarang kita sedang menjalin sebuah kerjasama dengan Balai Lingkungan Hidup yang di Gorontalo juga untuk aplikasi monitoring anoa gitu kan. Karena anoa itu kan hewan langka dan itu sudah susah ketemu sekarang. Jadi untuk ketemu, untuk ngitung jumlahnya saja nggak ada orang yang tahu gitu ya. Jadi kemarin kita sempat audiensi dengan kepala balainya dan yang mereka lakukan sebenarnya bukan pakai UAV ya, tapi mereka pakainya kamera trapping. Karena apa? Karena anoa itu kan warnanya itu kan cukup gelap dan agak susah dilihat dari atas gitu ya. Jadi untuk mendeteksi dari atas dari visual inspection itu kan agak susah karena pertama dari warna hewannya, kedua dari sisi konfigurasi hutan di Sulawesi. Hutan di Sulawesi itu kan tanamannya sangat ini ya, sangat padat gitu ya. Jadi susah untuk melihat dari atas gitu ya. Robot nggak bisa karena apa? Karena itu nggak bisa moving kan di dense forest itu dia nggak bisa moving gitu. Jadi yang dilakukan oleh kepala balai di situ adalah dengan kamera trapping. Jadi semacam CCTV. Mereka install kamera trapping di beberapa lokasi dan mereka merekam datanya berdasarkan objek yang lewat. Gitu. Jadi setiap kali objek lewat mereka merekam datanya. Nah, kamera trapping tersebut itu ditaruh di situ sekitar 6 bulan. 6 bulan, lama ya, gitu ya. Jadi mereka cuma balik ke situ tiap 3 bulan untuk mengganti baterainya. Gitu. Nah, masalahnya adalah kamera trapping tersebut kadang bisa jadi ada data yang tidak tertangkap. Atau kamera trapping tersebut karena dibiarin di hutan, itu bisa rusak karena hewan, bisa rusak karena aktivitas manusia, bisa juga dicuri oleh orang yang lewat di hutan tersebut, gitu ya. Jadi banyak challenge di situ. Nah, yang kita mau lakukan adalah kita bisa melakukan ini kamera trapping ini, tapi diproses secara lebih automated, gitu ya. Jadi kita bisa tahu statusnya pada waktu tertentu, pada waktu ketika objek tersebut dideteksi, gitu ya. Cuman memang problemnya yaitu connectivity itu tadi, gitu ya. Jadi kita sedang berpikir apa metodologi yang bisa kita lakukan dengan connectivity tadi itu. Mungkin LoRaWAN mungkin atau mungkin kombinasi LoRaWAN dengan seluler teknologi dan sebagainya. Itu kita baru memikirkan apa yang kira-kira bisa kita lakukan di situ. Nah, dari data sendiri mereka sebenarnya sudah punya data banyak tentang anoa yang di capture di situ. Gitu. Jadi kita pengen lihat datanya juga, dan kita pengen bikin mungkin bisa develop model ya untuk memonitor pergerakan anoa. Jadi itu work in progress ya, masih kita diskusikan. Tapi kita punya interest ke sana dan kita mungkin akan submit beberapa proposal untuk itu ya, dalam waktu-waktu dekat gitu mungkin. Jadi jawabannya secara singkat bisa gitu, dan memang itu yang kita sedang punya interest ke arah sana. Sebagai informasi, sekitar akhir tahun lalu itu ada sebuah artikel dari Oxford gitu ya, Oxford University gitu, yang mereka melakukan monitoring ini, tapi dilakukan untuk hewan primata. Kalau nggak salah orang hutan ya, orang hutan atau monkey gitu ya, atau ape, pokoknya ape species gitu ya. Jadi mereka ini melakukan deteksi, deteksinya bukan deteksi hewannya, tapi deteksi aktivitas hewannya. Jadi misalnya mereka monitor dari agak jauh gitu, apakah orang hutannya itu sedang makan atau sedang doing something else atau apa gitu, mereka bisa memonitor itu. Jadi itu yang memotivasi kita juga untuk extend this capability untuk memonitor hewan-hewan yang langka. Kalau orang hutan kan sebenarnya nggak susah karena kita masih banyak menemui di lingkungan hutan di Indonesia juga banyak, mungkin di tempat lain juga ada gitu ya. Jadi itu masih memungkinkan untuk melakukan real time monitoring seperti itu gitu. Tapi kalau misalnya hewan langka seperti anoa atau papirusa dan sebagainya, itu memang masih punya banyak tantangan di situ. Makanya ini jadi tertantang kan untuk bagaimana sih teknologi digital itu bisa membantu untuk konservasi satwa liar juga. Gitu. Tidak hanya tanaman, tidak hanya resource making gitu ya. Jadi kita punya interest di situ memang.
Oke, terima kasih ya untuk semua yang sudah aktif berpartisipasi. Mungkin dari saya sebagai moderator satu nih, ini kami dari teman-teman dosen di sini, ini kalau melihat penelitian yang sudah sebesar ini ya, maksudnya sudah sekompleks ini, itu mulainya itu lebih baik mulai dari kecil dulu, kemudian dikembangkan ke besar, atau mulainya dari sesuatu yang besar baru dipecah-pecah ke kecil gitu ya. Terus field apa aja sih yang dibutuhkan gitu ya untuk kalau khususnya untuk fieldnya ini ya. Gitu.
Ya. Wah ini pertanyaannya susah juga ya gitu ya. Perlu dua-duanya sih, tapi apa memang perlu orang yang punya visi pertama gitu ya. Yang maksudnya semacam mimpi gitu, bisa dibilang mimpi gitu ya. Terus dari visi itu kita bisa breakdown ke hal-hal yang kecil gitu. Jadi misalnya waktu itu ketika kita join project ini, kita nggak ketahuan, kita pengen ngapain gitu nggak ketahuan. Cuman title-nya hanya 5G Environmental Protection. Nah, 5G Environmental Protection berarti environmental protection itu kan sudah banyak. Dan kalau kita ngomong environmental protection yang digital itu rata-rata pendekatannya IoT based gitu ya, pasang sensor sana sini kalau teknologi data gitu ya. Kalau kita repeat seperti itu ya sudah banyak gitu artinya kan. Jadi kita harus mencari sesuatu yang unik. Jadi di mana yang sesuatu yang unik ini bisa memanfaatkan 5G sebagai enabler gitu ya. Jadi kita dari sesuatu yang besar ini terus kita coba petakan apa sih yang bisa kita lakukan 5G. Nah, makanya dari tadi saya sampaikan ada 3 komponen dari 5G kan, ada yang IoT-nya, ada yang latency-nya, ada yang broadband-nya gitu ya. Jadi IoT sudah cukup biasa. Ya, kita baru masuk ke 2 area yang lain, yang broadband-nya sama yang latency-nya. Nah, dari situ kita baru breakdown nih. Dari sini kita punya ada robot yang itu bisa lakukan, robotnya bisa apa. Terus dari situ kita breakdown lagi, dari manajemennya bisa apa. Dan terus dari sisi health of the forest-nya, terus itu kita bisa apa. Dari situ baru ketahuan expertise-nya apa gitu ya. Expertise-nya robot, berarti kita butuh robot expertise. Health of the forest, berarti kita butuh conservation specialist sama orang AI gitu ya. Manajemen, berarti kita butuh apa? Butuh orang yang paham misalnya enterprise sama information system gitu ya, karena itu lebih ke arah user interaction gitu ya. Jadi itu baru terkumpul timnya gitu, karena kita mulai dari suatu big, terus dari breakdown kecil, dari situ kita bisa collection expertise. Nah, big project itu tantangannya adalah risk-nya tinggi gitu. Jadi project ini waktu kita awal mulai itu risk levelnya itu tinggi. Artinya apa? Artinya potensi untuk gagalnya juga tinggi gitu ya. Potensi gagalnya untuk tinggi dan itu beresiko. Makanya saya suka bercanda sama kolega, sama teman gitu. Wah ini gara-gara project ini saya kehilangan banyak rambut. Jadi memang tantangannya memang banyak gitu. Jadi memang penuh resiko, tapi memang di resiko itu kalau kita bisa deliver itu rewardnya sangat banyak. Maka ya seperti award yang kita dapatkan itu sebenarnya itu tidak pernah kita duga sebelumnya gitu. Jadi ketika awal di project itu ya kita nggak punya ekspektasi seperti itu ya, kita hanya doing our task saja gitu kan. Nah kalau mulai dari kecil itu tidak apa-apa, tapi kalau saran dari saya sih secara pribadi mungkin yang pertama itu kita harus perkuat fundamental dulu. Jadi kita harus punya signature dulu dari research kita. Jadi research kita itu mau fundamental, tapi fundamentalnya ke arah mana? Apakah di data processing-nya, atau di arah misalnya architecture-nya, atau di arah sistemnya, gitu. Kita harus punya signature di research kita, gitu ya. Sebelum kita masuk ke arah applied research. Jadi saya bilang tadi yang 5G Connect Forest itu sebenarnya applied research, gitu ya. Jadi di situ kita harus memperkuat fundamental sebelum kita masuk ke application. Karena apa? Karena kalau kita tidak berkuat fundamental, mainnya hanya di application, kita itu tidak punya signature gitu. Jadi yang paling penting juga di funding gitu, di funding proposal itu yang paling penting signature kita. Jadi kita ketika kita mau doing misalnya 5G healthcare. Nah, 5G healthcare itu harus jelas. Jadi kita itu harus mau ngapain dengan expertise kita di situ. Apa yang kita istilahnya bisa offer on the table ke research tersebut. Jangan sampai kita hanya fokus di application tapi lupa pada fundamental. Nah, biasanya kesalahan banyak orang itu adalah mereka banyak main di application, karena application kan yang banyak uangnya ya, kita harus jujur ya. Application itu banyak uangnya. Cuman karena nggak diperkuat basic fundamentalnya, itu mungkin jangkauan 5-10 tahun itu risetnya jadi obsolete, out of date gitu ya. Jadi misalnya tadi pertanyaan dari mahasiswa mungkin ya, yang apakah 5G itu harus tergantikan? Ya 5G akan tergantikan, tapi kalau kita fokusnya risetnya 5G, ya nanti kita akan tergantikan juga gitu. Tapi kalau kita risetnya bagian fundamental di 5G-nya atau di data processing-nya, nah itu yang bagian fundamental tersebut yang nanti akan terrelevan dengan perubahan yang ada gitu ya. Maka saya nggak pernah bilang, oh, riset saya 5G enggak, riset saya fundamentalnya di information theory, jadi lebih ke arah information processing, baik dari itu transmission atau data processing-nya atau dari sisi storage-nya. Jadi semuanya berfokus pada information processing gitu ya. Mungkin itu yang bisa di-share yang mungkin.
Oke, terima kasih sekali Taufik. Oke, berarti itu tadi akhir dari sesi ketiga ini ya. Gitu. Terima kasih untuk semua partisipan yang sudah join, yang sudah aktif, dan juga nggak lupa untuk Taufik, terima kasih banyak. Thank you, nanti bisa keep in touch lagi. Next year bisa di-invite lagi ya, gitu. Bisa dikontak-kontak lagi. Oke, setelah ini saya kembalikan ke MC, nanti minta tolong ada foto sesi sebentar ya Taufik ya. Oke, dari saya, mohon maaf jika ada kesalahan. Saya akhiri. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Associate Professor Agustian Taufiq, Asyhari Bachelor of Engineering, Ph.D., and Mrs. Rismiati, Bachelor of Engineering, Master of Computer Science. Before we move on to the next session, we are going to do a short photo session for documentation. For all participants, we would like to have your cooperation to turn on your camera for this session.
Yuk, minta tolong di on cam sebentar ya.
Okay, taking a picture on my mark, 3, 2, 1. Okay, thank you. Once again, thank you, Associate Professor Agustian Taufiq Asyhari, Bachelor of Engineering, Ph.D., for your enlightening lecture.
Thank you, and izin pamit.
Ya, makasih ya. Maaf
Terima
telat
kasih.
dari jadwal. Oke.
Distinguished guests, ladies and gentlemen, our third lecture concludes today's visiting lecturer event. And now it is time for us to close this event. Thank you to the lecturers who has given us their enlightening lecture. We also would like to thank everyone who has participated in this event. We deeply apologize for any inconveniences that may have occurred during the lectures. We hope that all of us can learn a lot from today's lectures and see you on the next event of visiting lecturer. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Makasih Mbak Velia, makasih teman-teman. Makasih Pak Prajanto,
terima kasih
Pak
kembali,
Malik.
Bu.
Sendirian toh, nggak sama partner kemarin.
Sakit, Bu.
Oh sakit.
Iya.
Pak Malik sakit loh Pak Malik. MC-nya yang satu lagi sakit.
Kebanyakan lembur.
Oke. Terima kasih. Izin live ya, izin live.
Ya, izin live. Terus ini recording stop dulu aja ya. Alhamdulillah. Thank you. Yes.